Okay, so today, right? So today we will be starting with Hadoop administration. Okay, okay. So look at this. So today we'll be seeing the Hadoop administration activity. So if you look at the 17-page document, can you hear me, Ayyappan? Hello, hello, Ayyappan. Can you hear me?
Yes, Guru, I'm able to hear you.
Okay, fine. Start this. So now look at this. We have six machines. Okay. Aina, you're there.
Yes, Krishna.
Okay. You're fine now.
Sorry, just now I have seen the new link.
Okay. Okay.
I was waiting for, I mean, in the old thing.
I called you two times.
No?
Ah, yeah.
Oh, uh, I didn't check that. Sorry. Yeah, okay.
Okay. Okay. Well. Okay. See, we are going to see administration activity. See, administration activity is a set of predefined activity which you have to follow. So if you read this 17-page document, that's all. So you have to follow all the activity which is present here. So what are the activity, right? We will be adding the node, removing the node, copying the data, backupping the blocks, setting securities. So all those things is what we are going to see in today's class. So now to feel that multi-node cluster, so far we have been discussing about multi-node. That is a fully distributed environment. So we're connecting multiple nodes. Okay. So now we have almost six machines. So out of which one we are going to make it as a master, and the other we are going to make it as a slaves. And we are going to have a distributed environment and add nodes, remove nodes, all those things we are going to see with this new things. Okay. So with this, right, there might be a issue when you restarting the Hadoop. Just I will say what to do to bring back your system. Okay. So all the IPs are correct, right? So now, so all the username and password is same. Yours different. Okay. So yours is HD user. HD user. So Hadoop is not started, right? Okay. Now same HD user, HD user. Same, right, Anand? Okay. So we have 5 machines. So your password is different, right? Okay. So now we have a HD user 1722, the first six missions, right? So we are going to configure that. Okay. First six mission we are going to configure as a master and slave. So 17 belongs to Muthu, right? Okay. So now we will rename the machine one by one because all the machines having a mission name as Ubuntu. Okay. So it has to be identified by a proper name. Then only it will be easy for us to change the configuration. Okay. So if you look at the steps what I have given, so one is this, other is Hadoop multi-node configuration. One document will be available. Okay. So one is this multi-node cluster will have all the details. So just you can follow this. Okay. So that's what we are going to do now. So the first step will be updating the machine name and then updating the host name of each and every machine. Will be reflecting the master. One machine should know the details of other machine. So that's what we are going to configure now. So first step will be we have to change the name of the box from master, that is Ubuntu, to master, and rest of the machine to slave 1, slave 2, slave 3. So whichever the way you want to name it, you can name it. Okay. The only the prerequisite, right? The host name. So by default, how we configure by the host name. Host name is the machine name, and as well as we have a DSN name. Okay. Fully qualified data DNS name we will have it. So that DNS name will not change it. Even when the IP changes, the DNS will be fixed. In real time, we will have the DNS name. So since we have the environment here, we don't have the DNS router. We go by the IP. So in real time, don't ask for the IP. Don't configure by IP because when you restart the machine, the IP address will change. So that's the reason I've requested not to change the IP address. So Ayyappan and Anna, is it clear on the context what we are trying to do?
Yes, Guru, clear.
Okay. So now the host will change it. So if you go to this, okay. So you can check the host name of the machine. So you can edit by changing this sudo nano etc host name. Okay. So the same sequence I'm going to give. Yes. So all the machine does not have the sudo enabled, right? So this is 17 host machine. So you're not enabled sudo, right? Huh? Ah, that's what 1 minute. Ah, no, no, no. Everything you said, right? When you start Hadoop, it is asking or not? Okay. So this one I'm making it as master, and that's what name node is master. Then 1 2 1 2 3 like that. Name node. Okay. So this machine name is, we have to restart. Huh? Right. No, unless the new machine comes, right? It will launch it. Okay. Name node. No, no, one by one we'll do it, because at the time you do it again the IP will change. So only one machine, same IP will come. If you do parallelly, right, each and every machine will get a different IP. 17. Okay. Yes. So this machine I'm doing. So likewise I'm doing for all other machine. I'm doing one by one so that the IP we get the same IP. Okay. Data node one. Okay. So see the name and the IP what I'm giving, so that if I make mistake, correct me. Okay. And is it clear what we are trying to do?
Yes, Krishna. Actually, what is the purpose for using sudo nano etc hostname?
To change the computer name.
Okay.
Okay. Sudo is a administration user, and we are editing the computer name.
Hmm.
Okay. This is data node one, and next we are going to give us data node two. Is my machine name. 3, right? So now we have changed the name of 6 machines. So one is name node, others are data nodes. Okay. So now the next step is very important step. So this is where a lot of problem will come. Okay. So what happens, right? The master should know what are the slave machines. The slave should know what are the master machine. So what we will do right now, we will go ahead and update the master and the slave details to the all the machines. So to do that, we have to update the host file of each and every machine. So now in the host file, we have to update like this. So that is what's your master and what's your slave. Okay. So now all the machine of IP address should be present in all the machines. Okay. So in this case, so this is the detail we have. Okay. So now we have to change this to master and slave details. So in this case, so all the machine will have details like this. Okay. So you can copy paste this one. Okay. So if you look at here, you have to comment the details for Ubuntu because that Ubuntu no more exists. Okay. So 1.1 we have to comment. And the same the local host, right? You have to give for this as well. 1.1. From that, the next details is okay. So now the first machine is a name node. So check the spelling. Okay. If I make the mistake, tell me. Mm. We are not going to connect with host name. Host name is to identify which machine is data node 1, 2, 3 like that. If any machine has a problem, we will not go and check what is IP address. If you know data node 2 means who is data node 2. Okay, you are data node 2. Go and check it. So naming for a machine, that's all. So 23 is the last machine, right? Okay. So data node 1, data node 2, data node 3, 4, 5. Okay. So these are the details of the machine. Check it. 17 is name node. Rest of the things are 22, 24, 26, 25, 23. Okay. Data node 1, 2, 3, 4, 5. Huh? 1.1. 1.1 also you have to give. So that will be a loop back. In the machine itself, it will look for two things. 1.1. Remember for HBase I have said, right? For HBase this configuration is required. Huh? Which one you didn't understand? 1.1 by the 0.1, 1.1. Okay. When it connects internally, it will use the local host. When it connects across the machine, it will use IP address. See, for any machine, you need a local host by default. Okay, because any service which is running, it will look for that machine. That is a local host. Okay, in Windows, any environment you take, there will be a local host. Local host will be that local IP. Okay, that is the meaning. Apart from that, when you want to connect the machine from remote, that's a public IP. That is what name node. 1.1 is the internal IP. So, internal machine IP itself. Particular machine internally, if you want to connect, so that time it will look for 0.1 and 1.1. Okay, when any application is running, it will look for the local host. So HBase you remember, so it will look for 0.1 and as well as 1.1. So that is a security mechanism to connect to that internal machine. Internal machine is machine connecting to machine itself. Application being running and connecting its own machine. So that's what local host. Okay. Every machine, same local machine. Wait, இருங்க வாங்க. Wait பண்ணுங்க. Okay. See here, I am changing this. Okay. So now all the details of all the machine I am updating. So right now I'm updating the host name of all the machine to know the details of other machines. Okay. Okay. So now we have configured the IP address so that 23 knows what is the machine name of the other machine. So now the next important settings, right, Bala? If you want to come, because that is the important step. If you miss that and if you proceed further, it will not work. Okay. So now we have made all the machine to link. The next thing is right. We have to provide a passwordless access to other machines. So from a name node, you should connect to the data nodes, and data nodes you should connect to the name node without password. Okay, that's called SSH configuration. So to do the SSH configurations, right? So what happens, right? The HD user on master. So when you connect with HD user at master, SSH HD user at master means it should connect to the other machine. So similarly, vice versa, from a data node to the name node, you have to connect. So that configuration you will be performing with using the SSH we configured with the other machines. So what you can do, right? So for example, when you do from this machine SSH data node 1 at no HD user at data node. Okay. So now if you look at it is asking for a password. You got it? It is asking for password. So now if you give HD user, it will connect. So from here I have connected to the other machine. So I will exit. So now if you use again it will ask password. So this is called password based connection. So now what we have to do, we have to make it as a passwordless access. So how do we do it? So you remember we have used SSH. You have to generate a key and then followed by that you have to copy that key so that any machine which comes, it will be allowing the access from one machine to another machine. So then followed by that, when you use SSH master, without any problem, it should connect. So that's a main aim. So now we will generate the key for each and every machine. We will generate one key, copy that key to all the machines. Okay. So now we are in the master. Okay. So now we are going to connect, copy the key from this machine to all the machines. Okay. So which means that the master key you are copying to all the machines. Got it? So if you look at this, HD user and master must be able to connect to its own user account, master, SSH master. Okay. In this context and not necessarily SSH localhost. It should not be localhost. So that's the reason we are configuring name node and their IP address. Okay. To the HD user account on slave machine via passwordless access. So if you follow this step, you can do this. So now we already have the key which is generated in the master, because your key, you already have a key. So that key we are going to copy to all the 10 machines. So 10 machines knows who to allow. Similarly, what happens when master connects to that machine, slave machine, it will check for the authorized keys. So the authorized keys which is available in master, available in slave means it will allow the connection. That's the main aim of it. So now look at this. Okay. Now you see it. Already we have generated that key because it's a single node setup, right? We already generated the key for that. Okay. So because copying to other machine. Okay. So similarly, data node 2. Ah, didn't do its connecting. Okay. 3, right? So this is very much very important step. Okay, if you miss this, it is not working means the connectivity will not be established. Because from that, if you are connecting master, already key will be there, right? I'll show you that. It will not communicate. Already authorized keys only it's there. The r.ssh.pub, right? It will write to authorized keys only. Shit. 5, right? Okay. So now it's got communicated between the machines. Okay. So now if you check SSH master and SSH slave, it should communicate. Okay. So from your master machine, you have to try SSH name node. It will communicate without password. Okay. Similarly, SSH data node 1. Okay. SSH data node 2. Not required. One time we established all the connections, right? Uh, no, now here after it will connect only with the IP address. Name node is HD user. Uh, right. Uh, okay. So it's a very good question. Okay. So for one time you have to configure Hadoop only with one user only, root user. Okay. So only that user can start Hadoop. Only that user can communicate Hadoop because only the root user of key you have copied. If other user comes means it will not work because we have authorized only HD user to connect. Clear? That's a very good question. Okay. So one time only you have to configure. You cannot configure Hadoop with multiple users. Clear? So now similarly, why we are trying each and every step, right? Whether it's connecting or connecting, because that is mandate. If you feel it will connect and if you proceed further, there might be an issue. See, you see it? Because data node 5, right, as a different user. Okay. Not a HD user. So that time you have to connect with HD Hadoop user. So what we'll do, right? We will not use your machine because that might cause a problem. So all the machine should have that same user because we have connected HD user, copied HD user only to other users. So since when we use SSH data node 5, what will happen? It will try to connect SSH data node 5 with HD user. So that time it will have a problem. Okay. So all the machines should have the same configuration. So in that case, 5 data node instead of that we'll have 4 data node. Okay. So that is the reason I am checking each and every machine. Now we got the problem, right? Else what will happen when we start, right? We don't know why the problem is occurring. Okay. So that's the reason the username should be common when you configure. It should be a root user. You cannot use a different user because internally it will be connecting with SSH IP address, SSH host name, not host name, DNS name. Clear? No. So it's a common understanding that whenever you install in 10 machine, 10 machine should have the same user access. All will be root only. You will be installing only in the root user only, okay, or the privileged user. So that user should have access, because when you say 10 node means 9 machine one user, another one machine, it will not be another user. People will configure the same user in all the machine. Okay, that's understanding. Clear? Okay, so now we'll use 4 machine to connect. So now in this case, now we are able to connect to other machines. So that is the next step. No, we will not use the IP address in our master configuration. That's all. While we say which are your data nodes, that time we will not use that IP address. Clear? So it is good to, if you have 10 machines as well, check for each and every machine whether it's connecting. That connectivity is very much important. If you don't, if that is not connected, then you will have a problem. Okay. So from masters to slave, you have to connect to everything. The next step is, so this is an important step. Okay. Master versus slaves. Okay. So we know what's master and what is slaves. So we are going to have name node as a master and data node 1, 2, 3 as a slaves. So if you look at this, whichever you are saying as a master, in that only the respective Hadoop name node will be running. Whichever you are saying slave, there only what are the service will be running in slaves? What are the service will be running on slaves? Order, job tracker and task tracker. Uh, what are the service will be running on slaves? Task tracker. Is it correct? Okay, correct, right? On slaves only data node and the task tracker will be running. So now the next step is we have to update on the master only on the master file and slave file. Okay, on the master file and slave file, which are the name node, what are the slaves. Okay, so where you will go and update, right? So this is my master, where it is, whose machine is this? 17, where you install Hadoop. Bro? So here you will see a folder called master, file called masters. Can you see this? And slaves. Okay, so to the master file, you have to update name node. Clear? To the master, you are going to update name node. Name node is a system name. Okay, master we are saying name node, and then we have to update the slave file. What are the things you have to update? One. Okay, 5 we are not using, your machine we are not using. So you see here, only the things what we are going to use we have given. Just let me check it again. Okay, so now we have updated slave file and master file only on the slaves. So this is where in the slave file only you will be explaining what all your slaves. Okay, so if you have 100 slaves, you have to put 100 slaves in that one by one. So you remember while on the explanation how the data will be spread across the nodes. So when you have a different racks, the sequence of slaves should be alternate. So rack one slave, rack two another slave, so that the connectivity between across the racks. So don't put all the machine in one rack one by one. So all the communication and data spread will be happening the rack one, then only rack two will happen. Got it? So till this point is clear. Which means they are using master also as a data node. Okay. So for example, RAM configurations, right? Okay. I'll come to that. That is like a planning. We have a session. We'll come to that. So now, so once you update the slaves on the master, whenever you use start DFS, right now we are doing start hyphen all, right? Which means it will start master slaves, everything it will start. So data node always will come to slaves. So if you do start DFS or stop DFS, only in that case, the list of server which is present under the slave file will be used. Got it? So now the next step is we have to update site XML in all the machine. Okay, that is core site XML. Wherever we are pointing the local host has to be now changed into the master, that is name node. So by default in your location you have configured all the configuration, looks like localhost, right? Now we have to change it to master. Okay, so wherever you have core site XML, job tracker, okay, and the two locations you have to change. And we also update the replication factor to, since we have 4 machine, we can update to 3 and see how the copies are spread across. Clear? So parallel, right? You all configure a data node location, right? So can you remove the data alone in that folder in all the machines? You connect your own machine that the data node 1 you have configured, in that remove all the datas. Hadoop folder. If you remove that, everything will go. Not HDFS, in the Linux folder, Linux data folder, right? And name node also. What are the data you have? Don't remove the folder structure. Remove only the data, star of the data. That's all. Don't remove the folder, because the folder it will connect. Okay. So now remove that. Parallelly, what I will do, right? I will edit the configuration file of all the machines. Okay. So first the configuration of this machine, right? No problem. That's not, because in that machine only it will come and store. Okay. So nano core site XML. Okay, watch this and then you can change. So here I have to change it to name node. So look after any other thing. This is not a problem. Okay. Similarly, 22 whose machine where you installed 22, 22. எங்க பாருங்க. Okay, okay, I got it. What we have to give? What we have to give? What name node you are? This is the name node location, right? Bala, என்னாச்சு? I didn't expect this from you. So then we also need to change the map red site XML to what? Huh? That's the reason I said we'll give us a master. Now you see, if we give name node, right, people will get confused. Okay. So give a common name. Don't give data node 1 or data node 2 like that in the real configuration. Okay. Clear on this? Okay. Then in the HDFS site XML, so because we are connecting to multiple nodes, right, we don't need to stimulate multiple folders here. That is fine. It will not be used. No, it will not be used. It will be using only in this server it will use. Other machine will not have. Okay. So now, similarly, we have to come and change over here. So see the correct name whether I am giving. If I make mistake, tell me. Leave it, leave it. Here, I will still do it. Leave it. I will do it. So I will do it. You don't need to do it. So now, so here, right, change the replication factor to 3. So in Hadoop till Hadoop 1.2.1, right, that HDFS site XML will be present in all the folder, okay, all the data nodes. So the same replication factor put in all the server. It is not set globally, okay. Hmm. So check whether I'm setting the same property in all the machine. So that's the reason. அதுக்கு நீ இவ்வளோ ஃபாஸ்டா தேவையில்ல. Okay. So I have changed everything, right? Map red site XML, core site XML, HDFS site XML. Similarly, name node. data. Okay. Linux. Why? Because already that location data node is configured, right? That will use a previous version. So that time it will have a problem. That's the reason.
Krishna, what are the options you're selecting here?
A replication factor, and we have previously configured two locations for storage. So right now I am making it for only one location.
No, I'm not asking that.
Ah,
The bottom there would be write file, all those things,
control
right?
X,
Exit, help,
control X and Y, shift
control.
X and shift to Y.
First thing should be control X, and after that you should give Y.
Y.
Yes.
Yes. Whose machine is this? 20. Name node. Huh? Earlier. அதெல்லாம் மாத்துறீங்களா? Replication factor. Tab தான். Okay. So now we have completed that. Okay. So now all the folders, right? Okay. And then, okay. Okay. So now, hmm? Check it. Removed. Removed. One I removed, two I didn't check. Only one we are configuring. Two I am not using. That's not a problem. தண்ணி எடுங்க. தூர் 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 இங்க இருக்கு இங்க இருக்கு இந்த பாட்டில். So few minutes. Okay, one of our friend is very busy. Okay, now all the configuration done. Okay, next step is we have to format the file system. Okay, so this command you have to start from name node. Okay, Hadoop name node hyphen format. Okay, okay, so now it's successfully formatted. Got it? So the next step is like we have to start the Hadoop cluster. Okay, so this is where lot of now no now new Hadoop configuration. What data you had old? See, so assume this is a fresh Hadoop setup. Don't think that you already had a data or already configured Hadoop. Fresh Hadoop setup. Everything is gone. Already gone. Okay. Nothing is there. Hearing. Pantume. Once you clear the brain, it will not have a references for your data. The data folder I have already removed, right? Data node 1, I go and delete it. So now this FS image and edit logs we removed means it will not have a reference point for the data. And no point you having something in the data node 1 folder in each data node. That's why we deleted in all the folders and then we formatting. Clear? Clear? Salva. Simple. Don't remember that you already had Hadoop, it is removing. No, it's a fresh setup. That's all. Fresh Hadoop setup. When you do a fresh Hadoop setup, what we'll do? Follow the steps, right? Same. That's all. So instead of I am configuring fresh machine 10 machine, I'm using all the machine already available. Already all the softwares are available in each and every machine. Just I'm using that. I'm altering few things to connect. That's all. Okay. Same version. Okay. So now clear. The next step is where ah. So now we are going to start the Hadoop. Okay. From master you have to run this command. So name node is starting. Data node 1 is starting. 2, 3, 4 started. Okay. So JPS name node job tracker here it will run. And in 22 it's not running. Okay. 26 it is running. Okay. 25 it's running. Okay. Okay. 25 whose machine? 26, 24, 22. Okay. Uh, We'll see. One minute. Okay. So now, hmm. So now if you look at the live nodes is 3. Okay. 1, 3, 4. It's starting. Okay. What is 1? This is 21. Okay. Right. 1, right? Oh, no. See here. 1 has issues. Okay. CD livex no such file directory. Okay. 4 it's starting. 2 also not starting, right? 2 has issues. Okay. 1 dot livex no such file directory. Okay. 3 it's starting. 3, 4 it's starting. So your 2 and 1 has some issues in your Hadoop. Where? Wait. This one is software. That here, same. Okay. Under the okay. So now, uh, softwares. You're saying it's software, right? Yours, what's the problem? Okay. So the problem is when you are installing, right? All the Hadoop you will install under opt slash. Okay. So which means the path will be same in all the machine. Okay. So in this case, what it will try when master is starting, it will go and trigger the Hadoop in that particular path. So it will start DFS under that location. So it is looking for the same path. So that's the reason it has issues. Okay. So now in this case, if you look at, if this is the problem occurred, what you can do, right? You can go and start the data node manually. From master, if you're starting the data node, it will look for the path, same path. So you can go ahead and start the data node and task tracker individually in that each and every machine. That time you already configure what's the master, so it will communicate. So you remember previously I started data node 1, it is communicated. That's the reason it is showing 3 live nodes. Clear? So now, no, not really. Huh? 1 minute. You got the problem, right? Everyone got the problem, right? So home, home, HD user, lab, software, Hadoop, bin. Okay. So in that, if you look at start DFS, so that will start the data node. And if you want to start the task tracker, so other way is to do, right? Hadoop daemon. 1 minute. Start data node. Okay. So this will start the data node. Okay. And then we have to start the task tracker. Similarly, we have to start the data node in other machine. Okay. So now data node and task tracker is running. Similarly here, data node and task tracker will be running. Okay. So now if you refresh here, you will see 4 nodes. Can you see that? 1, 2, 3, 4. 4 nodes we can see that. Just now we started, right? So now you see it will change. Now it's changing, right? Just now we started, right? So now you look at what is the used GB, nothing we have used, and data node 1 and 3 and 4 has some blocks. Okay, it will change. So now we have a 4 node cluster. Clear on this? That is a metadata. Initially it will have one data node, it will have that. Okay. So now so wait for few 5 minutes. Okay, and then again we'll test it. What happens in a big node cluster after 5 minutes or 10 minutes only, you'll know actually all the data nodes are standing. Sometime it may go down because of communication problem. Ah, we can do that. So wait for few seconds. Okay, once all this started, because it will take some time to sync up. Clear on this how to set up? Annie and Ayyappan, is it clear? The multi-node setup. So this, there are a lot of commands where individually you can go and start it. Okay. So now see data node 2 is getting some blocks. Clear? You can connect. We didn't copy it. That is a metadata. That's all. It's not a data, it's a metadata. Okay. So now we'll copy some huge data and see what's happening. Okay. Clear so far? See this, I'm showing you, I'm taking much time to demonstrate this multi-node in a different machines. What happens, right? If I can connect with the NAT and show the settings. Okay, by default, what happens? The same VM, if you copy and paste it, you don't need SSH because already the SSH you're copying it. It will communicate everything. I'm connecting different machines, assuming that we have 5 servers we're communicating. So we will stop one by one and see what's happening. Okay. So during stopping of one server, don't restart any machine because you will get a different IP. That time will have issues. Okay. So now we are in good shape to start with that. So all the machines will check once again. That time we have to see any configuration. Might have removed, not removed any folder. That's not an issue. Okay. So now we have the uh, 4 data nodes available. Now we will copy the data. So 17 is your machine, right? You have any data in that machine? Hmm. Okay. So now we will have a data here. Okay. Target. Tarapona. Okay. Okay. So now if you look at here, I have a huge data here. So there is a Okay. So now you look at here. I have a 517 MB file. Okay. 517 MB file is there. So which I am going to copy to this machine. Okay. So this is the data I'm going to copy. Structured. Okay. So if you want to create a huge file from a small file, you can use a syntax like this: cat statement followed by that new file. So all that will be appended and it will be giving to a new file. Okay. If you want to generate a huge file. So one file we are merging into, if you want to generate 1 GB file, okay, where you don't have 1 GB file, you have to download, means you don't need to worry. You can directly create that in a existing file. Since you don't have the file, okay, I'm copying from my machine. Uh, hmm? That is KB only, right? Since we have replication 3 and we have 4 nodes, right? I want to show how the spread is happening. So 4 nodes means 517 divided by 64. How much? It will come almost 517 by 64. Okay. It will come 7-8 blocks. So it will spread to the 4 nodes and come back to the beginning. So that I want to show. I am copying this data, txns, 17. So now what I will do, right? I will merge this to a new file. Okay. Eighty-one sixty. So what I did, right? I'm clubbing all the txns file and making a big file so that you can see how the blocks has been spreading. Okay. So now I'm going to copy this data to the HDFS. So HDFS we don't have any folder. So I'm going to create a folder called input. Ah, okay. And I'm creating a folder called txns under input. So under that folder, I'm going to copy this data. So fs minus copy from local txns com, right? So now the data copy will happen. Huh? We are going to. So now while copying, you can see this. So it's 600 MB, right? See how much time it's taking. So it also depends upon the response from the node data node as well. So is machine RAM, that particular data node response time, everything it depends. Yes. So always the name node configuration should be I when compared with the data node. All the data nodes should have the same configuration. The name node should be I because it is controlling the all the nodes, right? So if the data node is having 16 GB RAM, the name node at least minimum 32 or 64 GB RAM it should have. Server, it is not a machine. It's all racks. Laptop, it will not. Lenovo, that all-in-one PC has 64 GB RAM. This much time it should not take. Now we see blocks are changing. Used is changing, right? Not name node we are putting. So the name node will split the data and give to the nodes. Okay. So now we go over here and we browse the file system. Okay. And this is going to, so this is the data we are copying. Okay. So 3 replication factor. So in this node, it is having a 120 MB of data. Okay. Data node 4. So still the copy is going. File 600 MB. Hmm. Name node. So now you see in the server it has 192 MB. Okay. So if you click this, so now if you look at 1 minute, if you look at now, hmm, data node. Some other machine that core is one, someone has given that. Okay. Core 1 2. So what happens, right? All the machines should have a equal capacity. So when this data node 2 it's writing, it's not getting a response, means it will wait for that till it moves to the next one. So someone machine is very slow, that's the reason it is taking time. Else this 800 MB and all, it will copy in a few seconds. Okay. So by default your core should be minimum 4 core machine, So the configuration which I have given right before, we will again go through that. Speculative, right? So what is questions, right? Speculative executions, right? So that is related to the running of jobs, copying not. So what happens that time, right? So when a job is running, you can give a more priority to a particular job. So that job will be getting a more preference. So right now it's a copy only. Speculative execution. Okay. So now you see the blocks are copying, and it's for almost 10, 14, 18 blocks so far. Okay. So if you go and see this, browse file system, user, HD user, okay, 320 MB only it's copied. So we have almost 640 MB. Okay. So it will take almost another few minutes to complete. So now if you look at here, so almost here total number of blocks is 6. Okay. So 6 unique blocks. Understand the 6 unique blocks. So 6 into 64, 3000, 320, 350 MB. Okay. So that's what we have seen there. Almost 320 MB was copied. So now you look at 320 MB blocks. 6 blocks that are copied, it will change. So now if you refresh again, it might change. 7 blocks. So it is keep on copying. So you remember the interview question during the copy of the data, in between if any failure, whether the data will be available for access or not. So this shows that the data will be available for access. Clear? This is one interview question. And the next is number of blocks is 7, but 7 into 3, 20, 21 blocks. If you go to the live notes, 6, 6, 12, 12 plus 5, 17, 21 blocks. It is equally distributing. If you see the distribution, it is equally distributing the nodes. So now if you look at here, this block will be present 3 times. So the block ID is same. It is present in 26, 22, 25. Is there is a sequence of copy? No. Alternatively, if you look at this block 25, 22, 24. So one block, so if it will start 26 is the data node means 26, 25, 22 it will come. Use here 26, 22, 25. So it will always change from the 1, 2, 3 means if it starts from 2, 3, 4, 5 it will come. Cyclic. The next thing, right, if you look at here 26, right, the next block it will put at 25. 25, next it will start. Always current data node plus 1 will be the replication will start. You got it? Current node plus 1 will be the replication it will start. So if third one, so third one, okay. So that block, if this block might be present in 22, okay. The next to 22 will be what is the next? You got it? So if that is the last one means it will come to the first one. If it is in the fifth one means if the block is fifth, so the copy will happen from first 1, 2, 3, 4, present plus 1. So that will be based on the list of the nodes how you configure. Okay. So that's how internally it will copy. Clear on this? So now if you refresh, it might change. 9 blocks. Okay. So always the copy will be current block plus 1. That is the theoretically logic. Okay. Theoretical logic. Practically there might be a situation it will not go by that as well. If that connectivity or the kind of a processing response is low, it will might change to next node. Now got it? Theoretically n plus 1 will be the next replication it will start, and you might see the block ninth will copy, but it will not wait to ensure that the replication is completed. First the write will complete, parallel the replication will start. One more interview question added to this, right? So you got it, Arena? One more interview question added to this. When all the data is copied, then only the replication will start, or while copying itself the replication will start. While copying itself the replication will start parallelly. So the replication is not for the data entire data, it's for the block. Clear? See, I'm going into this detail because any interview question you should answer. Clear? Clear? Kumar knows how. Okay. One more it will come. So total 10 blocks write is completed. Clear on this? Clear on this? 10 blocks the write is complete. See how much. If you go and click this, you so if you look at here, 26 is data node 3, 1, 4. Huh? The IP on the I have configured some host in my local machine. Okay, that is front name node only. Okay, it will that the metadata right. It will go and look randomly. It will go on it. That browse file system if you give right, it will not go a single one. It will go randomly. But end result is like it will go back to the name node, and this has been populated from the name node only. Okay, 10 only. 600. No, no, no. That is wrong. So the size is 6 not. Say take 600 MB. 600 divided by 64. 9.3. That is a 10. 10th block will have a small small data. Clear? Is it clear? This should be crystal clear. This is very much important. Okay. Now 30 blocks will be there. 9987. Correct? Huh? 9 9 9 18. 18 plus 8 26. 30 33. Okay. Why is that? Metadata also will be there. So after writing that metadata also will be considered as a blocks. Okay. Clear? Clear so far. So you need a break. So next thing is how to disconnect, how to add, decommission, everything we are going to see that. So how many minutes you need a break? Sharp by the time you have to be here. Huh? 10:26 now, 10:30. Huh? 10:45 will be there. Okay. 10:50, 20 minutes break. Be here by 10:50. I know you will not come at 10:45. That's the reason. Okay. Fine, Annie. So we'll start back at 10:50. Okay, the break starts now. Okay. Okay. So now look at this. Okay. So one of the machine was powered off. Okay. Data node 1, data node 3 was powered off. Okay. So now if you look at here, you switch it on. Okay. No, data node 3, right? It will take 600 seconds to know that it is failed. So now you watch this. Previously it was 9. Okay. So now you look at 33 is been splitted across 3 nodes. Clear? Clear on that? Actually, it is dead. Data node 3 is dead. Okay. You see the last contact 317, right? It will wait for 600 seconds. Where it was not there? Huh? Okay. That graph it's not showing. Here you see. Here the bar is not showing, right? Okay. Okay. So now you look at this. So this data node 3 is down. It is contacting 369 and wait for almost 700 seconds, 600 to 700 seconds. It will wait. Okay. After that only it will be decided. It will be totally down. But internally it is known it is down. That's the reason the data spread has been happened between the nodes. 33. Previously we had 33. The 33 again copied to different nodes. Clear? So now if you look at this browse file system, seconds, last heartbeat, 1 second before it has connected. So it will be sending the heartbeat. Okay. So now you look at, can you see this? This block, it's been copied into 4 nodes. Why? Because out of which one node is down. Okay. So if that comes back, that node will be removing that data. So we'll see that. Okay. Clear? $470, right? Another 5 minutes. We have to wait. It's almost 700 seconds. It will drop. Live node will become 3. Then the replication will change. So once you bring back the machine, again it will check the metadata. That time it was there 4 nodes, right? You see it is there in, if you refresh this, or data node 3 only is down, right? Now you see 1, 2, 3, 4. The number of blocks not changed. Only the replication same copy is putting into different nodes.
I'm able to hear. Are you able to hear me? Yes. Able to screen. Able to see your screen. Are you able to hear me? Hello?
Yeah. Okay. Is it fine now, honey? Okay. So now you see above 600 seconds, it came to 3 nodes. Can everyone see that? Okay. One node is dead, and it will go to the dead node. If you go to the dead node, so dead node is different, decommission is different. Okay. Dead node means totally down. Decommission is something you explicitly doing that. So now if you do this, one node is dead, one is live. So now after this, if you come back to this, you see the metadata is not getting changed. The block is pointing to different nodes, but if you see this data node 3, it was down 26. Okay. Now it has been copied to this. But if you see the block dead node, all 26 is pointing to the last. Can you see? The first 3 only it is taking. The last all the things are 26. So 1, 2, 3, 4, 5, 6, 7 blocks was there in the data node 3. Clear? Now it's been moved and it's been copied to 24. So it is not that only now 3 nodes are available. 3 replication factor means all the nodes will have all the blocks. That's the concept. 10 blocks will be there in all the blocks, all the nodes. Now you power on your machine. So now we are bringing back the node from the dead node to live node. So now we'll see what's happened here. Okay. So what happens, right? He didn't stop anything. Okay. He just opening the machine so that the machine powered on. Hadoop service will be still be running. In case Hadoop service is down, you have to start the Hadoop service. That is the data node and task tracker, as I said before. Okay. Started. Only start your machine. Now you see live node is coming. Okay. Not required. So data node 3 is coming in live. It will change. So it will take few minutes to refresh the nodes. Apart from that, if you want to refresh immediately, you can also refresh the nodes. So you can refresh with the help of DFS admin, refresh nodes. Okay. Other way is like you can. So one is to refresh the node. So immediately Uh, it will take time. Okay. So this node, whenever immediately, if you want to immediately refresh the dead nodes and live nodes, you can use this. Other way is like you can also use a balancer called Hadoop balancer. So what this does, right? It will balance the blocks across the nodes. So now, okay. So what happens, right? That is a predefined level. We'll have it. So if you use this, what is the percentage of disk capacity? That's called threshold. 40% of capacity, you can use it to balance across the nodes. That's the meaning of it. So now, so all that parameter replications, right? Immediately it will not happen. It will take some time. Now you see it's changing. So this will reduce one by one. It will, so it will decrease and it will increase. So likewise, the data spread will come back to its original state. That is to ensure that the block is spread across all the nodes. It will remove from one particular block. Okay. Or else, if you want to immediately do it, if you restart your Hadoop, it will check the metadata and it will remove the other blocks. Okay. So what happens, right? For an end user, they will not know whether the block is removed or not. But while the job is been processing, it will process the first three blocks. 26 it will not take care. So when again you rebalance, it will take few seconds to remove that, because that is not mandate. So that is the reason, if you look at all the, if you look at all the failed nodes are present under the last block only. Okay. So it will take certain time to come back. Clear? Clear on this? So now it will take time to refresh. So now we have four nodes. So we went into the mode of shutdowning a machine, and then it goes to dead nodes. Hmm. Uh, Come in. 1 minute. Come again. You can shut down. If you don't want again means you have to decommission. Okay. Okay, data node 3 was down. That's the reason it was copied back. So now the data node 3 is back, so it is refreshing the metadata. Okay, so this, right, I'm showing you how the spread will happen. It will change. So after few minutes, right, again it will change back and it will distribute the into 3 replication factor. Okay, and as well as you'll have only 3 blocks. So in this case, if it shows 4 blocks, right, but the last one will be unused. It will change, it will take time. Okay, immediately it will not happen. So only the ensure guaranteed is given, right, the data loss will not be there. That's all. நீங்க எது question கேட்கலாம்? Okay. No, no, it will accept parallelly. That will happen. It will not wait for that. So that's only when you restart Hadoop, that safe mode will happen between merge between the FS image and the blocks. Apart from that, whatever the whenever you give the data, it will accept the data. Yes. Okay. So now we will exclude. Okay, we'll exclude certain nodes and then we'll see what happens. So right now we are going to exclude the data nodes. The exclude of data nodes, what will happen? It will not get any new data which is going to come. Similarly, you can also exclude the job tracker. So any job if you submit, that particular node will not get the job processing, map reduce processing. Okay. So now dfs.host.exclude. Okay. So what you can do, right? Huh? Exclude means that particular node will not be used by any client. Dead node means no one can use it. For example, I am patching a server. So I want to exclude from accepting the data to that node. So that time it's decommission. Okay. Decommission means the server will be live, but Hadoop will not give any data or work to that server. Detach, attach, like that you can think of it. That we are going to do. Yes, decommission to remove permanently for certain time. So the word decommission might be looking like permanently remove it. Okay. So but in this case, decommission is like detach and attach. Exclude, do certain work and attach back. Okay. So like this, you have to maintain an exclude file. Okay. And you have to list the list of nodes. So right now we'll do that. So in 17 server, I'm going to create a file called exclude. Hmm. Conf. So you write. So I'm having a file called exclude. In that I am making data node 4. Okay, as a decommission. So I'm saving this file. Okay, after saving this file, you have to come and update the HDFS site XML to the path where you are configured this exclude. So now in our case, I am configuring under this under hdf site xml, you have to put this property file. Okay, so property dfs.exclude. So whatever the list of servers you added under the exclude file will be present here. Okay, so now after you transfer that, so that is for the HDFS. Okay, the next thing is like you have to refresh the node and balance the node. That's the two thing you have to do it. So the refresh the node, okay, and then once you balance this, timestamp iteration bytes already moved, bytes left to move being moved. Okay, so now three nodes 22, 24, 26 is being balanced. Decommission in progress. Okay, one node. Now you see it, the split was happening. You see that previously it was 9, now it's changing. Okay, so if you come over here, decommission node. Okay, so which means any job you submit, any data you copy, it will be under replicated blocks is 2. Okay, it is keep on moving. Once it decommission node is not equal to dead nodes. Okay, so now if you come back to this, you see again the copy has been happening. 3, they're not 3, right? 26, 3, right? Now 4 only we stopped. We stopped 4. Now you see, okay, so it decommissioned. Once it decommissioned, the way it distributes the data will be across the 3 nodes now. Now you have 12, 13, 12. So when you do a decommission, explicitly you tell that node to detach. Dead node is automatically the node goes down. You got it? So for example, when you do want a patch, you remove that, make upgrade, then include that. So during the exclude after you excluded, right? When the node comes online as well, it will not automatically use it. Why this decommission and commission is required, right? If you have 100 nodes, 50 node goes down, 50 nodes comes automatically. The way it replicates and gets the data back, that time it will create more network traffic. Okay, so you should not go and stop and start a node. You should exclude the node and then do it. When you exclude, right, the decommission progress is happening. That time it will update the metadata properly. Clear? It will update the metadata properly and it will notify the name node that one node is going to down, and we should not include for any process during the data copy. Okay, or any job which is set, we should not include. That is the understanding of it. So now if you do this, decommission is decided by us. Okay, now you see previously we add a blocks. Okay, so that time it was copying randomly. Once you decommission, it is done properly. Okay, properly it will do. Why this is to avoid the automatic replication. If you have 1000 nodes, right, 500 node goes down, 500 will start replicating to 500. So that time it will crash the network. When you do this with explicit of Hadoop telling I am going to go down, so please take my data whatever you want, so that the data loss is not there and is properly being replicated. No. So in this case, 26 is the live node. Data node 3 is live. So what happens, right, is putting equally next to next. 20, 25 here. So if you look at this 25, okay, if you click this, it will not connect. Okay, it will show that no, it will not go, right. Previously we dropped 26. It will not go from the list. Only that node, it will not be accessible. Metadata will still be there. This is the metadata. When you open the data only, it will not be there. So if you go to 24, okay, it has some data in it. Okay, you see, it has some portion of a data in it. There's a cut which has happened before of this is the continuity of previous block. Clear? You see here, clear now. You don't need to balance. Okay, automatically it will do it. You will say 40% use as a threshold level. Explicitly you are telling, it will do automatically as well. You can say explicitly 40% is a threshold limit while you are transferring. So what happens, right, while transferring, if you give 100%, right, some disk might fill. So equally distribute, having a 40% as a threshold limit. That's the meaning. Okay. Mm. Mm. It will happen when you do balance again. It will start copying the. uh, okay, so that's why we do start hyphen all that sh. So you will not go to 50,000 node you have means you will not go to 1,000 node and start one by one. You will start from the master only. As a end user, you will not have any activity to the data node at all. You got it? So once you start, right, it will issue the start command parallel to all the 1,000 nodes. Again, it will copy the data. So we did, right. So that is the reason when you start means it will go in safe mode. It will go to safe mode. So it will check all the blocks what is already available and the metadata details of which server, whether that server is alive or not. So that time it will take time to replicate the metadata with the data nodes. So that time only it will not allow you to add any data or delete any data, but you can read the data. Safe mode time 5 minutes to 10 minutes it will take, but it is depends upon the volume of data. How much volume and how much metadata you have, we cannot decide. So if you don't want to go safe mode, that's why you safe mode off. Okay, that metadata and the block sync only it will happen. That time only it will verify what are the nodes which is available, delete, all those things will be decided. Okay, clear. So we stopped the fourth node, right. If we come to the fourth node and do a JPS on this, you see data node will not be running. Can you see? Because we excluded from a name node, it explicitly issued a command of data node stop. Clear? But in the case of previous, it will be not accessible. In this case, it is explicitly stopped the data node. Clear on this? Yes. Okay. We only stopped excluded the data node, right? Not task tracker. Okay. Data node that is a server in which data node and task tracker service. We only excluded a data node. Okay. Yes. You cannot avoid that. So that's where the administration will come. That's why the node down and bringing up, right? It is not a minute job. Sometimes it will take 30 minutes, 1 hour as well. Okay. So that is where uh, the servers, what we go, right? The downtime of a server is very low. Theoretically, it says 1000 node, 50, 500 node goes down, but 500 node will not go down immediately. Got it? If it happens, so this is the problem. That's where we have a different tracks. Hmm. Hmm. Okay. Decommissioned and then dead node. First it will decommission and then it will go under dead node. Okay. So now, yes. You have to come and check. Here you see, right? Initially it was under the decommission node, right? Okay. Again, now if you start that as well, it will go under decommission node only. If the data node you start as well, it will go under decommission node. In 1.3.1, it will not go to dead node. It will be in decommission node only. It was decommissioned, then it went to dead node. Because in 1.2.1, it is explicitly sending a command to stop the node. In 1.0.3, it will not do that. The data node will be running, but it will not be utilized by the master. So that time it will show under decommission node. Okay, clear? Now, similarly, if you want to exclude, so this one map rate dot host. So this is equivalent to task tracker. Okay. So you have to put this in a, all you have to do in the master. See, we are not doing any activity on the data node. Okay. You have to put this under the map rate set XML. So now, right now we did for data node. That is HDFS site XML. Right now we are doing for a task tracker. That is under map rate site XML. Okay. So now you refresh the node. So this you cannot see in online UI. So this you will see only when you submit a job tracker. That node will not be used. So why this, right? You don't want to use a particular task tracker because the task tracker has some issues. In that case, you use this command. Okay. When you don't have, for example, you don't want to use that particular task tracker, it has some issues. In that case, you want to exclude from using that. No, data node. The understanding is like that's what I said. It is master and slave. In slave, data node and task tracker will be running. Data node is for storage. Okay. Task tracker is for processing. When we exclude the data node, the storage will not happen. Yes. Okay. Practically both should be down. Both. Yes. So practically both should be down. In some cases, only task tracker they might bring down to avoid the processing of data in that server. Okay. So practically when you bring down, you should bring both the things. Okay. So when you exclude that, you will not see in online. Actually, that's what I said. The naming, right? We should give master slave. That time this confusion will not come. Node, not server, data node service, excluding the data node service. Okay, clear? This is the property. No, it will not run. See, logically both should be down. Okay, so this shows how to bring one by one down. That's all. Only that particular node task tracker. Exclude file. This one. It will read that. Okay. Yes. Clear? Annie and Ayyappan, is it clear?
Yes, bro. Clear.
Remove name node itself will not do. That's what, instead of that only we go for exclude. Because if you want to do this right, you have to remove from the slave file and start again. So that time only 3 node will be used. So right. So this right, where all will be used, right? For each and every, for example, when we go for automated number of nodes in cloud, we are saying, right, 1000 node, 100 node. It is not that 100 node, it's configuring. Okay, it is, listen, 1000 node, the company will build 2000 node cluster, for example. I need only 10 node, means that time it will create a slave file only for you as 10 node server. So out of 1000 node, 10 node will be used for you. Got it? Got it? So that's the reason it says 1000 node cluster, means you have to request how many node you want. So only that many nodes slave file will be created for you. So when you access, the 10 nodes only will be used for you. So that's where the exclude and include files all will come into the picture. Okay. So for your user, what are the nodes to be included? Clear? Yes. Okay. So for example, right, the company has given a budget for 1000 node, but the company will say right now use only 10 nodes. So they will put everything in the exclude. So they don't need to configure again 800 nodes. Right now only 10 nodes will be used. So if they says add few more nodes, means they will include. So that time that another 100 nodes will be utilized. That's the whole point of this. If you remove from exclude, it will be included. 1000 nodes will be in exclude. Remove 100 nodes, it will be, that will be included automatically. Ambari, Apache Ambari, that will do a multi-node configuration. From one server, you can deploy in all the servers. Apache Ambari. For that, you need a DNS, because it will communicate from one machine to another machine. Host, that network setup we have to Apache Ambari. It is for managing your cluster. Okay, it's a simple tool to manage your cluster. Only for Hadoop. Hadoop. Okay. So now Similarly, if you want to include any node, you can include. Okay, dfs dot host, if you include, it will include the nodes, or the other way is like from exclude you remove it, that is include. Same, both are same. Okay, include means, for example, if a new node is coming, you have to include means you can also include. You don't need to go and change in the slave region servers. You got it? If 10 nodes are there, another 10 nodes I have to add means you don't need to go out and add to the region server and start Hadoop again. Okay, so in the time you can put in a dfs.host include file, you can just refresh it, the 10 nodes will be used. So this will be an entry question. 100 nodes are been using, I need 10 more nodes. Do I need to update the slave file and then I have to restart my Hadoop cluster? No need. You can put a dfs.host and add an include file, the 10 nodes will be added. You got this question right? 10 machine you have to start the data node and task tracker, that's all. So this will be an important interview question. Okay, because the people are using 1000 nodes. For adding 5 nodes, why I have to restart my cluster? So it will affect the entire system. Instead of that, how to add only the 10 nodes? So we have to put the new 10 machine under the include file and add this property. Okay, so that time what it will do, just you have to go and change the parameter here and then start data node and task tracker in each and every machine, that's all. That, that is all remains same. Only the thing, right, there is no downtime for Hadoop. That is the main thing. We can start the data node separately. Okay. ஃபார்மட்டே மறந்துடுங்க, ஃபார்மட்டே பண்ண மாட்டோம். Okay, so, okay, when you start first time, all the data nodes will get the same version. You remember the version I showed in the version file of data node? When new node comes, it will connect to the master and then get the version and updates. Clear? That's how it syncs. Okay, so exclude, refresh, update job tracker, we have seen. Refresh node, balancing, add disk space, we have seen. Include. Okay, okay, so your machine powered off on 3, right? Oh, the username is incorrect, right? So, fine. So now till this point is clear. Commissioning and decommissioning, balancing, refreshing the nodes, everything is clear, right? So now next thing we are going to go for backup and recovery. Okay, so the backup and recovery, right? If you want to explicitly specify the file to be used for name node, okay, or you can also specify what is the checkpoint directory. Okay, these two things are important. So save secondary name node checkpoint. What this means, if you are copying the data to other nodes, at what checkpoint it has to copy the data from the name node to the secondary name node. So if you look at here, okay, so here we have the secondary name node also which is present. There is a checkpoint which will be managed from the name node and the second name node internally to ensure that there is a backup available within the machine. So what checkpoint interval it has to copy between the name node folder and the secondary name node folder is what the condition. That is an important backup and recovery mechanism. So in this, if you look at, Okay. So if you go to this, there will be a two folders. HDFS. There will be name node, primary and secondary. So one we are using for name node, another use for secondary name node. So both will have a same data, but there will be a checkpoint interval. So 5 minutes once, then only it will move to that other folder. So what checkpoint you have to ensure? To ensure there is a proper backup is available. Checkpoint means uh, checkpoint interval. Okay. So for example, you remember we have set this property. Okay. Checkpoint interval. So here where there will be a checkpoint will be stored. What was stored before to the secondary name node? What was the latest? So what has to copy? That checkpoint it will be storing under this location. So this we already did for our cluster. Checkpoint copy. Remember right? fr.checkpoint directory. So now, so this is to start explicitly the secondary name node and as well as HDFS secondary name node checkpoint force, which will immediately copy the data from the node to the secondary name node. Okay, these two things. So this right, if you stop the secondary name node, the secondary name node will be stopped. Hadoop host minus master, which means in this case we have to change it to name node. Okay, start secondary name node means secondary name node will start. Stop secondary name node will stop. After starting, if you want to update the name node metadata to the secondary name node, you can force the checkpoint. So which means the checkpoint will get updated and copy the latest FS image and the edit logs to the secondary name node. And in our case, the secondary name node in this case, it is in the same machine, but practically it will be in a another machine. Clear? Clear? Separate machine, I said, right? You remember there is another machine where you will have the same master copy again. In that case, the secondary name node will be down. Okay, so that time you have to point the right now we have given slash hdfs slash this, right? In that time you will give the actual path of that machine. So IP address followed by the, that will be a shared folder. So that time it will copy the data from this folder to other folder. So the secondary name node will be running in another machine. It will, that is in the mapper version. So one data node will act as another secondary name node. So in our case it will be a separate machine. You can use it, but when it's down, right, both master and slave will be in same machine, right? It will not be a distributed processing. Both master, job tracker, data node will be running in same machine. So that's the reason we go for a new machine. Clear? Clear? Clear arms? So this is save namespace. Okay, so which means whenever you are changing anything, safe mode enter means it will not accept any new data. So for example, when you are taking backup, so that time no one should write the data to the Hadoop. That time you make it to safe mode enter, and then no one will save it, and then you save the namespace. Namespace saving is, so right now you make it this to enter, safe mode enter. So safe mode is on. Now whenever anyone is trying to write a new data which is updating the metadata, it will not allow. Okay, then you save the namespace. Remember, it updates under the namespace directory. Okay, there will be a namespace directory under which updates the metadata, all the metadata. And then if you want to take a copy of it, Okay, so now it's created a file name called file name dot text. So that is a file it's created. So if you go here, fs minus ls, uh, 1 minute, wait. So you see, so this is the details of that fs image. So you remember we add a details. So this what it does, right? This is what meta file. You can also view that namespace meta file like this. Okay. So what happens, right? In this fs image, we have the list of metadata information. Okay. Where is it? So right now we copied only input transaction txns com, and what is the size of the data it's showing. Okay. all the subfolders and what all the data which is storing, all the metadata, it will show save over here, show over here. Why this is required, right? So when you have the application 100 users are using so much data you stored, and you don't know the location where the data is there, and you cannot go in and search for a particular folder or a file, so that time this will be useful for you to export and see this is the location the data is there. So this is what that meta save also will do it, file name dot text, so which will give you the list of data, so you can also view like this. So that command, it is storing the data, but which location it is storing, created a file on server node, where it's creating. Okay, so this is same as this one. So you can view the, you are saving the namespace and you are exporting. You can also directly you can export by using this command. Okay, namespace means this metadata. So if you want to view the metadata and export means you can do this export. Okay, so why we need this, right? If you go to browse folder, you have to navigate one by one folder. You have to go to txns and then go to that, but this will give all the path. So if you look at this, this will give both the parent and the child path. Txns, it will give input txns, under that what data, what is the size of the data, what is the permission of that, everything you can see in this. Okay, that file name is storing but it is not there in the metadata, we'll see that. Ah, okay. Ah, so this is right, this is the another internal project people will do, metadata search. Okay, so it will tell you which location the data is there. So if you stored one file called hr.text, but you don't know which location it is there. So right now we have only input and output folder, but in a big cluster you don't know where you stored last week that file. That time they will give a metadata search that will export this file and search and give you a result. Okay, huh? Name mode use பண்றதுதான், export பண்ணி அத metadata பார்க்கிறோம். It is like backup. So someone comes and says I stored my data, it is not there, that time this will be useful. Yes. Okay, clear. uh, primary name node டவுனே பண்ண மாட்டோம். primary name node டவுன் ஆச்சுன்னா secondary name node வந்து primary act ஆகும், primary ஆயிடும். அது primary மாத்தணும், நம்ம மாத்தணும் அதை. இந்த கரெக்டுப்பா, இது நம்ம ஃபர்ஸ்ட் கிளாஸ்ல பார்த்தோம், ஞாபகம் யாரா சொல்றீங்களா? அடூப்போட மாஸ்டர் ஸ்லேவ் ஃபைல் அங்கேயும் இருக்கும்ல, செகண்ட் நோட்லயும் சேம் செட்டப் தானே. செக் பாயிண்ட் வந்து ஒன்லி எஃப்எஸ் இமேஜ் காப்பி, but slave file வந்து we have all the data nodes, right? So secondary name node is equivalent to the primary name node, you will replicate and have it. When you start again, you have already the list of slaves, right? Hmm. Data nodes la, see we are only saying name node, we are not saying any other name. Name node you have to change the IP address of the secondary name node. சொல் உங்க டவுட் கிளியரா சொல்லுங்க, உங்க டவுட் என்னன்னு. சரி 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 ஓகே ஆ எது பிரைமரி ஆக்ட் ஆகும்? அது ஆக்ட் ஆகுது, நம்ம தான் ஆக்ட் பண்ண வைக்கணும். அதுதான் அந்த ஃபோர்ஸ் பண்றோம்ல நம்ம. இப்போ டவுன் ஆனோடனே அந்த செக் பாயிண்ட் ஃபோர்ஸ் பண்ணீங்கன்னா செக் பாயிண்ட்ல இருக்கிறதும் காப்பி ஆயிடும். சி சிம்பிள், எது காப்பி பண்ணாலும் பிரைமரிக்கும் செகண்டரிக்கும் ஒரே ஒரு இன்டர்வல் காப்பி கேப் இருக்கும். ஓகேவா? 10க்கு காப்பி பண்ணீங்கன்னா 10:4க்கு ஃபெயில் ஆச்சுன்னா அடுத்த காப்பி 10:5க்கு தான். அப்போ அந்த 4 மினிட்ஸ் டேட்டா இருக்காது. ஓகேவா? அது செக் பாயிண்ட்ல இருக்கும். ஆ இப்போ நீங்க செகண்ட் நேம் அப் பண்ணும்போது மொத்த ஃபோல்டரையும் காப்பி பண்ணுவீங்க, அங்க எல்லாமே காப்பி பண்ணுவீங்க. அந்த நேம் நோட் பி இருக்கிறது எல்லாத்தையும் காப்பி பண்ணி நேம் நோட் எஸ்க்கு மாத்திடுவீங்க. ஓகேவா? எஸ்க்கு மாத்திட்டு நேம் நோடுக்குன்னு ஒரு ஐபி கொடுத்தோம் பாத்தீங்களா, அந்த ஐபி வந்து புது மிஷினோட ஐபியை மாத்திடுவீங்க, செகண்ட் நேமோட ஐபியை. ஆக்சுவலா அது வரேன், அது வந்து அதுக்கு தான் டிஎன்எஸ் நேம்னு சொன்னேன். நீங்க என்ன பண்ணுவீங்க, டிஎன்எஸ்ல போய் மாத்தி விட்டுருவீங்க. ஸோ டிஎன்எஸ்ல வந்து நேம் நோட் டாட் கேப்ஜெமினி டாட் காம் அப்படின்னா பிஃபோரா வந்து 1ன்னு ஐபி இருந்ததுன்னா இப்போ 2ன்னு மாத்தி விட்டுருவீங்க. எல்லா ஸ்லேவுக்கும் அந்த டிஎன்எஸ் நேம் தான் தெரியும். அந்த டிஎன்எஸ் நேம் எந்த ஐபிக்கு இன்டர்னல் பாயிண்ட் பண்ணுறது டிஎன்எஸ் சர்வர் பார்த்துக்கும். இப்போ இந்த கேஸ்ல நீங்க எல்லாத்துலயுமே மாத்தி தான் ஆகணும். நம்ம கேஸ்ல மாத்தி ஆகணும், ஏன்னா ஐபி அட்ரஸ் யூஸ் பண்றோம் நம்ம. மாத்தணும். ஓகேவா? தோ அதுக்கு தான் நம்ம மூணாவது ஆப்ஷன் சொன்னல, நீங்க அந்த லொகேஷன் ஆஃப் நேம் நோட் பியை வந்து ஒரு நாட் ஸ்டோரேஜ் வச்சிருந்தீங்கன்னா கரெக்ட் ஆகாது. ஸோ ரீகலெக்ட் த ஃபர்ஸ்ட் கிளாஸ் 3 option I said, right? One is interval copy, checkpoint copy, and the third one is like NAS copy. So that file will be present in the network access storage. That time you can copy it. NAS போட்டிங்கன்னா ஒரே இதுதான், லோக்கல் ஃபைலுக்கு பதில் நீங்க வந்து அந்த இதை மவுண்ட் பண்ணிடுவீங்க. NAS வந்து மவுண்ட் பண்ணுவீங்க. அப்போ டிஸ்க் ஃபெயிலியர் ஆனாலும் சிஸ்டம் ஃபெயிலியர் ஆனாலும் மவுண்டட் டிஸ்க் வந்து வெளியில தான் இருக்கும். ஓகே, இது பாத்தீங்கன்னா இது வந்து பாத்தீங்கன்னா உங்களுக்கு வந்து இந்த நோடுக்கு பதிலா அந்த நோடு யூஸ் பண்ணணும்னா இதை ஃபோர்ஸ் பண்ணிட்டு எடுத்து போவீங்க அங்க. இப்போ நீங்க பிரிங் டவுன் பண்ணணும், பிரைமரி பிரிங் டவுன் பண்ணிட்டு செகண்ட் யூஸ் பண்ணா அப்போ ஃபோர்ஸ் பண்ணிட்டு எல்லா காப்பியும் ரெடி பண்ணிட்டு எடுத்து போகணும். இது எதுக்கு இந்த ஸ்டெப் அப்படின்னா, டக்குன்னு பிரைமரி நேமோட ஸ்டாப் பண்ணிட்டு நீங்க எடுத்து போனீங்க வச்சுங்க, அந்த செக் பாயிண்ட்ல இருக்க டேட்டா எல்லாம் செகண்ட் நேமோட போவாது. அதெல்லாம் ப்ரீ டிஃபைன் ஸ்டெப்ஸ் வச்சுக்கிட்டு, இல்ல பிரைமரி நேம்ல இருந்தா நீங்க வந்து கான்ஃபிகர் பண்ணணும், இல்ல பேட்ச் போடணும், பிரிங் டவுன் பண்ணணும் அப்படின்னும் போது Hadoop கிளஸ்டர் வந்து டவுன் டைம் வந்து 5 minutes 10 minutes தானா. அப்போ வந்து ப்ராப்பர், இப்போ சிம்பிள் பா, உங்க மிஷினை ஃபார்மட் பண்ண சொல்றேன், எடுத்தோடனே ஃபார்மட் பண்ணுவீங்களா? பேக்கப்லாம் எடுத்து வச்சுக்கிட்டு அதுக்கப்புறம் ஃபார்மட் பண்ணிட்டு திருப்பி பேக்கப் பண்ணதெல்லாம் காப்பி பண்ணீங்களா? அதுதான் பண்றோம். பிரைமரி நேம் நோட்ல இருக்கிறது எல்லாத்தையும் ஃபோர்ஸ் பண்ணி எல்லாத்துக்கும் மெட்டாடேட்லாம் சேவ் பண்ணிடு அப்படின்னு எல்லாத்தையும் சேவ் பண்ணி வச்சுக்கிட்டு செகண்ட் நேம் நோட் அப் பண்ணிப்போம். பிரைமரியில காப்பி பேஸ்ட் பண்ணிட்டு ஸ்டார்ட் பண்ணா போதும். பிரைமரி ஸ்டாப் பண்ணுவாங்க, Hadoop ஸ்டாப். அங்க போய் ஸ்டார்ட் பண்ணிடணும் Hadoop. டேட்டா நோட் எல்லாம் ஸ்டாப் பண்ண மாட்டீங்க, ஒன்லி டிஎஃப்எஸ் நேம் நோட் ஸ்டாப், ஜாப் ட்ராக்கர் ஸ்டாப், அவ்வளவுதான். கரெக்டுப்பா, நீங்க டவுன் பண்ணா கூட மாத்தினாலும் அதுக்கு போய் ரிக்வஸ்ட் எல்லாம். இப்போ 3 சர்வர் ஆக்ட் ஆயிட்டு இருக்கு, இப்போ 3 சர்வர் இருக்குப்பா, 4வது சர்வர் ஆட் பண்ணி டிஎன்எஸ் போய் ஐபி அட்ரஸ் மாத்தினா அந்த டிஎன்எஸ்க்கு இனிமே எந்த ரிக்வஸ்ட் வந்தாலும் அந்த புது சர்வருக்கு போகும். ஐபியை நீங்க மாத்த தேவையில்லையேன்ற, டிஎன்எஸ் நேம்ல போயிட்டு 2 சர்வருக்கு பாயிண்ட் பண்ணதுன்னு வச்சுக்கோங்க. ஒரு சர்வர் டவுன் பண்ணா டிஎன்எஸ் ஆட்டோமேட்டிக்கா அந்த ஐபி இன்னொரு ஐபிக்கு போயிடும். நீங்க ஐபிக்கும் டிஎன்எஸ் இது பண்ணிக்கிறீங்க, கன்ஃபியூஸ் பண்ணிக்கிறீங்க. நீங்க வெறும் ஐபி பேஸ்டா இருந்தா மட்டும்தான் ஓகே. இருங்க இங்க பாருங்க, அடுப்பே வேணாம். டவுன் டைம் கண்டிப்பா இருக்கும், டவுன் டைம் இல்லாம இருக்காது. ஒரு 5-10 ஒரு நாள் இருக்குது பதில் 5 நிமிஷம் 10 நிமிஷம் இருக்கும், அவ்வளவுதான். ஓகே, இப்போ டேட்டா நோட வந்து 600 செகண்ட்ஸ் கம்யூனிகேட் பண்ணினே இருக்கா, அந்த 600 செகண்ட்ஸ்ல மாஸ்டர் அப் ஆயிடுச்சுன்னா கம்யூனிகேட் பண்ணிக்கும். கிளியரா? இப்போ இது எல்லாமே மாஸ்டர் போய் ஸ்லேவை கம்யூனிகேட் பண்ணது இல்ல, ஸ்லேவ் தான் மாஸ்டர் கம்யூனிகேட் பண்ணது. மாஸ்டர் டவுன் ஆச்சுன்னா 600 செகண்ட்ஸ் ஹிட் பண்ணினே இருக்கும் அது. அது அதுக்கு தான் நான் சொல்றேன் நேம் நோட் வந்து சிங்கிள் பாயிண்ட் ஆஃப் ஃபெயிலியர். நம்ம ஃபர்ஸ்ட் கிளாஸ்ல நம்ம இதை டிஸ்கஸ் பண்ணுவோம். நேம் நோட் தான் சிங்கிள் பாயிண்ட் ஆஃப் ஃபெயிலியர். ஒன்னு டவுன் ஆச்சுன்னா கிளஸ்டர் டவுன், நீங்க டேட்டா நோட டைரக்டா கம்யூனிகேட்டே பண்ண முடியாது. ஸோ அப் ஆனோடனே மாஸ்டர் அப் ஆனோடனே இட் வில் கம்யூனிகேட். இல்லைனாலும் ஒன்றும் பிரச்சனை இல்லை, திருப்பி ஸ்டார்ட் பண்ணீங்கன்னா ஸ்டார்ட் ஆயிடும். சரி வாங்க நம்ம நெக்ஸ்ட் போகலாம், இன்னும் நிறைய இருக்கு. ஸோ சேஃப் மோட் என்டர், we will go to safe mode enter and then we'll save the namespace. Okay, so whenever you want to save, whenever you want to do Hadoop upgrade, okay, but these steps are not, it is a steps to do it, okay, but rarely the steps are executed. Got it? So upgrade they will not do it, only in the rare cases they will do it. So what are the steps if someone asks? Remember this. Okay, so first you can check the upgrade process, stop all the jobs which is running. Okay, so this is a file system check. So what happens, right? Which block is present where? So if you go here, do you see here? So which means under user transaction com 10 blocks are there, which are the blocks having which data. Can everyone see this? Only now 3 servers is there. The metadata of the 4th server instance is gone. Clear? So previously that metadata it was having, now you see I said right it will take time to refresh. Now it got refreshed, right? Previously it was having 4, now it's saying 3. So this all end user will not know, but I'm showing internally what will happen. So now why this require, right? To know which block is present and whether the status is healthy, okay, and all the details what you are seeing in the online you are seeing in command line, because you cannot go and click each and every block and see what are the blocks available. With this command you can export to a log, this is called file system check, and see the health of that file. Got it? Got it, Muthu? So before upgrade you will do all this to verify whether that metadata is copied, all the blocks are back, all the things you will do it. That's the reason we take a backup of this. Similarly, this is for the namespace. Okay, so this is like what we did for a metadata, right? This is for the namespace. So similar like we did in the previous statement, this is, yes, all the details will get it. Similarly, if you want to do for list of data nodes available in the cluster. Okay, data node 3, what are the IP address? Okay, safe mode is on, and one more data node, and one more thing. One is dead. Okay, one is dead. So total live nodes available is 3, 4 total nodes, but one is dead. Okay, all the details it will give you. So you see the status of the thing decommission. Someone asked, right, how to check whether that node is decommissioned. In 1.2.1 it is going at a dead node, but in 1.0.1 it will be in decommission, but internally the status it is showing decommission. So the decommission status is normal. Can everyone see it? You see the DFS used will be 0 in this case, in the case of decommission. In the case of dead node it will be there, but it will not be live. That's the difference. When you decommission and refresh the node, it will automatically take the data. There will be a question: what is the difference between dead node and decommission? It will not remove the data, but decommission it will remove the data and it will give to other nodes, ensure there is no data loss. But dead node data will be available when you restart as well. Now if you go and check the nodes, this node will have 0. I said, right, if the node is replicated 3 blocks, 1 block will be removed. Now you got, right, how this been happening? Hmm. Same data, but same copy will be again in another node, right? That it will copy. Already there will be another copy will be in different. Deleted. It will be there, but it will take time to get deleted. Okay, when you redistribute, right? If the nodes is copied back, the preferences will be given to the new node. The dead node which is coming back, that blocks it will delete. Delete. So that, see, that is right. That is where the failure of a dead node is to be low when compared to decommission. Decommission time network traffic will be low. Dead node network traffic will be high, because irrespective of the nodes it will start copy. But decommission it will calculate how many nodes it has to copy, how many blocks it has to copy, delete, everything will happen gradually. In the case of dead node it is not like that. Clear? Clear, Annie and I am clear on.
Yes, clear.
Okay. So real backup. Okay. So right now we are not taking the backup of the data, because you cannot take a backup of Hadoop. Clear? This backup to ensure that there is no data losses available when you are doing any activity on the Hadoop cluster. Clear? So backup means you can move a data from this Hadoop node to another Hadoop node. That I will show you how to do it. Clear? Huh? That like that will not do. New cluster. New cluster. Version change, right? What will happen? um, Data node wise they will not change anything. See, the data location will still be there. You got it? The data location still be there, everything will be there. Only the upgrade is like they will not change the version, just like that 1.2.1 to another 1.2.1. That is where the problem occurred in open source. So when you stick on to a version, when you are doing an upgrade to a newer version, it is a long process. Okay, so the long process is where you have to take up all the backup of this to ensure again pointing back the metadata again. Clear? So optionally, if you want to back up the list of HDFS data, you can do it optional. Okay. Okay. So now see here. If you have Hadoop 1.0.3, okay. So now you have Hadoop 1.2.1. In that case, you can have Hadoop 1.2.1, fine, and change the environment variable of Hadoop 1.2.1. But you cannot move from 1.2.1 to 2.0. That is a full migration. So in this case, you point the latest version of Hadoop location. Okay. In that time, Hadoop start name node upgrade. It means from the old location to the new location, it will start upgrading. That time you can go and check the status of upgrade. So Hadoop DFS hyphen upgrade progress status, right? So you add the version. There is a name node version 0.41. If you go to the lab, HDFS, name node P, current version you have, right? Storage type name node layout version -41, right? So this will be the new for another version 42. That time it will check what is the version of the name node and then it will start upgrade. That upgrade it will do for the metadata. Okay. That time you can check the status and then you start the data node after pointing to the new Hadoop directory. Okay. So that time you can remove from the safe mode and finalize the upgrade. This is to move from 1.03 to 1.2.1. So this tryout condition, right? It is a very rare condition to do it, and lot of it is not like a. It is like moving from SQL 2000 to 2005. It is not that simple to do it. It has various steps. So that time the block might not sync, communication might not happen, parameter might not sync. A lot of issues will happen. Just you can say the steps. Clear? Data wise, it will not change anything. Only the versions will change. So for example, 2.4.0 to 2.4.1, it will be easy. You got it? So that is like same generation of Hadoop with different versions. You can do it. Simple. We add Hadoop 1.0.3 in one machine and 1.2.1 in same machine, right? At a point in time, only one Hadoop can run. Got it? So similarly, you copy the new version of Hadoop and point the environment variable of Hadoop to the new version and do this activity. Point out the new directory, update the environment variables. Then do it. This upgrade will read, upgrade knows that we are changing something. It will maintain the old history of metadata and read the new version and update the metadata. That it will do internally. Clear? You can try this. No, when you change Hadoop environment variables, 1.2.1 will act. 1.2.1 will read the metadata of the previous thing and it will start this. Okay. So this is a backup. That's all. Okay. Why means after upgrading again you can check whether both are same. Clear? After upgrading you can check whether the list of nodes, list of metadata, list of blocks, everything is same. That's the reason we are backupping. So people will ask, how do you ensure after upgrade all the data is same? You can say metadata export and then do a comparison. Clear? Clear? None? Reena, Ayyappan? All the nodes will have the latest version. Okay. Same, same. Hadoop 1.2.1 means all the machines should have 1.2.1. Hadoop copy, if you copy the folder, jar file also will be copied, right? lower to higher தான், higher to lower பண்ணது. Okay, after getting from the safe mode, you start all the Hadoop name node everything, and then okay, layout version means each and every Apache framework has one version name. It starts from 32, 33. So they will change that version. Version is a framework has certain layout. Framework attached with the framework. Layout. Okay, so it is attached with the framework version code. So they will check only with the layout, right? 41, the Hadoop command depreciated means in this layout that version is that command is not there. That's the meaning. Okay. வரும் 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 இன்னும் நிறைய இருக்கு, முடிப்போம் பாருங்க. ஸ்க்ரால் பாரு வரும் வரும் ஸ்க்ரால் பார் எங்க இருக்கு பாருங்க, முடிச்சிருவோம். புரியுது கொஸ்டின். ஸோ வந்து சிம்பிள், நீங்க காம்ப்ளெக்ஸா யோசிக்காதீங்க, சிம்பிளா யோசிங்க. ஒன்லி அது ஜார் மட்டும் மாத்திரம், அந்த லொகேஷன் ஆஃப் டேட்டா நோட்ல சேம் தானே. Hadoop 2வே போகாதீங்க, 2 அப்கிரேட் பண்ணும்போது 2க்கு செப்பரேட்டா இன்ஸ்டால் பண்ணி ஆகணும். 1.2.1 நான் தான் கிளியரா மென்ஷன் பண்றேன். ஜெனரேஷன் 1ல இருந்து ஜெனரேஷன் 2 இந்த மாதிரி அப்கிரேட் பண்ண முடியாது, புது செட்டப் தான் அது. கிளியரா? ஜெனரேஷன் 2வே விட்டுருங்க, 1 மட்டும், ஒரே ஜெனரேஷன்ல மல்டிபிள் வெர்ஷன், அவ்வளவுதான். ஜெனரேஷன் 2 டோட்டலா கான்செப்ட் டிஃபரெண்ட், வில் see that. Okay, so applying quota, so you can also set the quota for the admin. So for example, if you set the space quota to 1 MB, okay, so what happens, right? You are requesting for a 500 node cluster and you say I need 500 GB of storage space. In that time you can set the quota for the directory, so only that particular user can store only 500 GB. Clear? Clear? Why? Because you are paying only for 100 GB. Okay, and my cluster is can hold only 10 GB. If you don't say that and if you don't restrict that, if someone is copying 100 GB, it will affect the system. That is the reason you can set your quota limit. Clear? Cluster level, directory level, everything. Set space quota means cluster level, quota for the directory means directory level, clear quota for directory, clear set quota for directory. Like us, you can set for the cluster, for the directory, anything you can do it. Nodes, but you purchase 10 node, okay, but within the 10 node you are trying to process 1000 GB of data, node with GB. Okay, so each node will have only 50 GB of storage space, but if you want to process 1000 GB, someone will buy 10 node and process 2000 GB data, they will not allow, right? So that time they will say 10 node means you can process only 100 GB of data, they will set the quota. So that's why you see quota exceeded, you cannot process by a node, another node. Clear? That time this will come. Clear? Where is the clear? Okay, this is an important command. Okay, so this is where distributed copy, this is called distributed TCP, copying the data from one HDFS to another HDFS. You see NN1 to NN2. I have two Hadoop cluster. For generation 1 and generation 2, generation 1 you have Hadoop cluster, generation 2 you have Hadoop cluster. Now you have to move the data from generation 1 to generation 2, data alone. That time you can use DSTP command to move the data from one cluster to another cluster. Okay, any Hadoop cluster. For example, I'm saying you can move the data from one cluster to another cluster. Clear? So Hadoop DSTP, HDFS of one data node to HDFS of another data node. Name node. Name node. Name node location then we'll give. Metadata will be there only, right? Okay, clear? One cluster to another cluster. Same generation, different generation it will work. Okay, clear? So actually this is how they will migrate the Hadoop. So the previous upgrade is a set of theory statement, but practically it will have a lot of issues. So what they will do, right? You build a new version of Hadoop, copy the data. Clear? Three days on. Okay. Configuring scheduler and queue. This is important. Okay. So now what happens? Allocations. Okay. So for example, it's a Hadoop cluster. Three different business units are using. Okay. This is the problem with generation one. Two we'll see after lunch. Okay. What happens? You also run the job. You also run the job. You have submitted a big job. You want to run a small job. That time, the small job has to wait for the big job to complete. So that's how Hadoop 1.2.1 is designed, generation 1. So after the queue is completed, then the queue will be allocated to the new job. How to overcome the situation in generation 1 is what called scheduling and configuring. So that you will allocate what is the maximum number of maps reduce, okay, and as well as for a user how many jobs he can run. Okay, so Anand is submitting 10 jobs. Kumar is submitting one job. But Anand 10 job will take 10 hours to complete. But Kumar need only 1 minute to complete the job. But Kumar has to wait till Anand the 10 job is completed. So the maximum Anand will utilize the cluster where it will not give for Kumar. That is the problem in generation 1 because it goes by the queue mechanism. How to avoid that? You have a mechanism called allocation. In the allocation, you can set a pool. Okay. The pool name is ads. In that only 10 and 10 mapper and 5 reducer you can work. This is one type of allocation. Okay. Mapped site XML. Mapped site XML. Parallelly right. But when one job parallelly for the job, not for across the job. See the difference, right? Job will run parallelly, but not all the job will run parallelly. Because everything to be taken care by one job tracker only. Clear? When one job is running itself, it will consume 85% of a memory. So it will not have a memory to another job. That's the reason it will not give the resource for the another job. So how to overcome that is what called allocation. So in this case, you create a pool and you say only 5 mapper and 5 reducer can be run for a particular pool. Similarly, the another allocations, right? You can set maximum number of job can be run. Similarly, you can after configuring all the pools, you can say for a user how many jobs he can run. So at a point in time, a user can run only one job. Got it? So likewise, you can say, so the answer will be, you can configure a pool and define your maximum number of map reduce, and as well as you can define the maximum number of jobs. That's called allocations. Okay. So this where you will do, right? As an administrator, people will come and tell, I am from a HR, my job is more critical. So give me 10. People who have less priority, give them less number of jobs. That is where allocations will come. User. Hadoop is running in single user, but everyone will not connect to that user. Okay. See, Hadoop cluster is there. You will not give the same credentials to everyone. You will add the user to the machine, Linux machine. So that Linux machine user will have an access to Hadoop. Clear? Clear? We are going to see. Hmm. Okay. So a user can run maximum of one job, and you can allocate a user to a pool as well. Under a user, you can see pool is equal to ads. So that user will be belonging to this pool. You got it? So you have 10 different pools you can create. So each pool will have different configuration. You can allocate a user to that pool. User group also you can add. Okay. So now you see here is the pool name is 1, and you have different parameters. See, um, minimum share of a map reduce. Limit the running jobs in the pool if the more jobs are submitted. Only the first max running jobs will be scheduled at a given point in time. Default to infinity or global pool max default value below. You can set only maximum number of jobs for a pool will be 5. Number of seconds after which the pool can permit the other pool task to achieve its minimum share. Requires a permission to enable it to a MapRed site XML by setting MapRed far scheduler to true. Okay, default to infinity. What happens, right? After 300 seconds, it can allow the other pool to also use the cluster. Okay, for example, if after 300 seconds the first pool itself is fully consumed, there is no chance of second pool coming into the picture. That time automatically after 300 seconds it will reduce the uh, resources for pool 1 and give the resources for pool 2. Clear? So now you see here user, you can set at the user level as well as pool level, both you can set, and you can also map a user to a pool. Pool level, user to pool level also you can set. Okay, you see pool max jobs, user max defaults, default level, and fair scheduler level. So 3 ways you can set: pool level, user and pool level. Okay, clear? Yes, allocation, it will give the allocation weightage to pool 2 because always it cannot allocate everything to pool 1. So that you can set, because some might user keep on running the jobs, it will not give a resource to pool 2. That time after 300 seconds the pool 2 can take over of the resource. Delay will happen. Delay will happen. Okay. Okay. So you can set your task scheduler, whether it's a capacity scheduler or fair scheduler. Capacity scheduler will be based upon the amount of jobs which is running. Okay. Fair scheduler will be based upon pool and user concept. Fairly it will schedule the jobs. Okay. MapRed set XML. Capacity based upon the number of jobs you can run. Fair scheduler based upon the allocation of pools. Okay. Based on pool based it will work. Capacity, majorly it is capacity. By default it's capacity. Fair schedule, if you want, you have to explicitly tell what is a fair scheduler, how it has to work. So fair scheduler concept, right? Fair scheduler, while you are using fair scheduler, your configuration should look like this. Okay, now you see it. Can you see here? Far scheduler, you will say what's your allocation.xml. Okay, and then you will say the pool name. So far scheduler will be working under the pool concept. You clear? So each and everything is a pool. Pool is a allocation, resource allocation. You can also allocate a pool to a user. So you see here, property pool name, what is the username? Clear? For that pool, what are the user you can say? Yes. Okay. That is a fair scheduler. Clear? Fair scheduler is allocation you can do by a pool based, and also you can allocate a user to a pool. So any user comes to that will be going to that particular pool. Fine, Lawrence? That is a fair scheduler. Capacity scheduler. So fair scheduler allocations will be like this. Just now we have seen, right? All that are fair scheduler. So what is the max, map task, reduce task? All those will be under allocations. Capacity scheduler is what you have to explicitly give in the mapper site XML. By default, it's a capacity, not pool based. Okay. So various properties are available for capacity. By default capacity. Okay. By default capacity, right? You can say maximum 8, which means for all the users, same thing. It is not by user by user. At this point in time, only 3 job can run. So any job, any user comes, it will be queued. Based on the capacity available on the cluster, the job will be running. 8 across all the users. 100 user also means only 8 can run at a point in time. So first user schedule means second user has to wait, no other go. But in the fair scheduler, you will allocate by a pool by pool. You can only run 2 jobs. Okay, so 2 job can be run by another user. That will be controlled by fair scheduler. Capacity scheduler by default across the cluster. Default, we can change. However we want, we can change it. Okay. See, for example, we have 10 chocolates. By default, if someone comes and takes 10, unless he completes and gives to other person, has to wait. That is capacity. I have 10 chocolates. I will group into 2, 2, 2. One person comes, I will only give 2. Remaining 8 is there. Another person comes, I will give 2. Likewise, that is called fair scheduler. Fairly scheduling. That is like a normal terminology. Clear? Clear? Hmm. It's queued, right? Only 2 allocation is already happened. The third one, if he runs, his job also will run parallelly. Anand job also will run. Kumar job also now it will run. Clear? அவர் என்ன டைரக்ட்லி கொடுக்குறாரோ அந்த அவுட்புட் வரும், அவர் என்ன டைரக்ட்லி கொடுக்குறாரோ அந்த அவுட்புட் வரும். Okay, so this is a capacitor Q. Okay, Q is equal to, you can say Q1 how much job should run, Q2 how much job should run. Okay, for example, so this is Q, right? It is based on user limit. When you run a job, Hadoop job, okay, you see set priority. Okay, set priority. So while 5 job is submitted, you might have a priority 1, 2, 3, 4. Okay, high, medium, low. There will be a very high, normal, low, very low. If you set the priority, the allocation of the number of memory and the resources will be good for very high job. At the same time, you cannot set all the job to very high. So why this is right? 5 job is queued. 6th job you are setting. When first job is completed, 6th job will give up preferences. Second job will not run. So 6th job will run second. Clear? By default, everything will be queued. Very simple. 1, 2, 3, 4, 5, 6. Seventh job you are setting, and but seventh job is very important. You cannot wait. Immediately I have to report to CEO. You set very high. When the first job is completed, the seventh job will be given a preferences to run second. That is called priority. No, while submitting the job, Hadoop job, you submit jar, right? At the final minus set priority is equal to very high. Yes. Okay. Clear? Hadoop job minus list will give you all the jobs. Hmm. See, start time, job ID, start state, start time, username, priority, scheduling info. வரும் பண்ணலாம் பண்ணுவோம் நிறைய இருக்கு பண்ணுவோம் ஒரே டேட்டா எப்படி எடுப்போம் அவரு ஒரு டேட்டா ப்ராசஸ் பண்ணுவாரு இவரு ஒரு டேட்டா ப்ராசஸ் பண்ணுவாரு சரி சி ஒரு ஹார்ட் டிஸ்க்கு நிறைய ஃபோல்டர் இருக்கும் அவர் ஒரு ஃபோல்டர் ப்ராசஸ் பண்ணுவார் இவர் ஒரு ஃபோல்டர் ப்ராசஸ் பண்ணுவார் இப்போ வந்து how to backup, how to exclude everything we have seen, how to run a job, maintain a cluster is what we are seeing. சொல்லுங்க any doubt? Automation, okay. So last week we have seen that OZ, okay, that is for scheduling a job. This is for inside the job tracker. So if I submit the job, that you can use with the cron, but that job will be submitted to Hadoop cluster only. Okay, clear? Clear. சொல்லுங்க உங்க டவுட் சொல்லுங்க. நம்ம தான் பார்த்தோமேப்பா போன இதுலலாம் ஜாப் ரன் பண்ணி ஸ்டேட்டஸ்லாம் பார்த்துருக்கோம்லப்பா பார்த்துருக்கோம்ல அதுல என்ன டவுட் உங்களுக்கு? சரி சரி ஒரே கிளஸ்டர் யூஸ் பண்றீங்கல்ல அதே கிளஸ்டர் தான்ப்பா. சரி நீங்க நம்ம இப்போ டேட்டா லெவல் பார்க்கல, ரிசோர்ஸ் லெவல் பார்க்குறோம். புரியுதா? if when you run a job it will be consuming 80% memory. If we submit the job, Hadoop will not accept. His job will be queued. Got it? So that queue, how you manage as an administrator to effectively allocate the resource available across the user. அதுதான் fair scheduler and capacity scheduler பார்க்குறோம். Capacity scheduler by default you can control for all the user. Fair scheduler you will allocate based on user. So for example, HR department, production business is there. You will allocate the memory according to their particular number of users. So you consume 50% of memory, you consume 20% of memory, you consume 10% of memory, like that. But when it goes to capacity, you as a production team, if you run the job, he as a HR team run the job, it will be queued. NQ and DQ as a concept. First it will submit the job. Unless the job is completed, other job it will not take. Clear? Huh? Queue. 10 job, if you submit 10 job will run one by one. And the queue will be decided based upon the number of mapper and reducer you can run at a point in time. Clear? See, that is the important point of Hadoop. When you go from one step to 3, okay, when you read 4, you have to relate it to 1 to 3. That is required. So what you are doing, only you are concentrating on fourth step. Read and recollect 1 to 3. Clear? So this is not with respect to only that particular portion. It is a continuity of 1, 2, 3 and fourth we are seeing. So added to that fourth we are seeing. Fifth we are seeing means you have to read fifth 1, 2, 3, 4 you have to relate. Clear? That one is clear. So that is called queuing. Okay. So this all related to queue, maximum, activity task, bytes, per user, how much bytes it can process, all those. It's a capacity scheduler. By default, it's a capacity. Okay. But in production, depends upon how much business unit they're using, they will allocate a fair scheduler. Okay. Clear abba, Muthu? அப்போ வந்து ஃபேர் ஷெட்யூலர் பண்ணணும் நீங்கள். அப்போ ஃபேர் ஷெட்யூலர் பண்ணணும். இப்போ நீங்கள் யூஸராக பார்க்கக்கூடாது, நீங்கள் இப்போ அட்மினிஸ்ட்ரேட்டராக பார்க்கணும். ஓகேவா? இப்போ ரிக்வயர்மெண்ட் வரும்போது உங்களுக்கு கொடுப்பாங்க, எனக்கும் இம்பார்ட்டன்ட் அவருக்கும் இம்பார்ட்டன்ட், நீங்கள் எப்படி எனக்கு அட்மினிஸ்ட்ரேட் பண்ணி கொடுப்பீங்க? ஸோ எஸ், கோ ஃபார் அ ஃபேர் ஷெட்யூலர். ஐ வில் allocate 2 resource, I will allocate 2 resource. புரியுதாப்பா? அந்த 2 ரிசோர்ஸுமே அட் அ பாயிண்ட் இன் டைம் எவ்வளோ மேப்பர் ரெடியூசர் ஒரு கிளஸ்டரில் ரன் ஆகுன்றது தான் ரிசோர்ஸ். அது உங்களுக்கு ஒரு 2 மேப்பரும் அவருக்கு 2 மேப்பர் கொடுத்துட்டுனா மேக்ஸிமம் மேப்பர் 4 இருந்ததுன்னா 2 ஒரு ஜாபுமே எடுத்துக்கும். கிளியரா? நீங்க அட்மினிஸ்ட்ரேட்டர் பாயிண்ட் திங்க் ஃப்ரம் அட்மினிஸ்ட்ரேட்டர் பாயிண்ட் ஆஃப் வியூ, டோன்ட் திங்க் ஃப்ரம் யூசர் பாயிண்ட் ஆஃப் வியூ. யூ சேம் a requirement, my Hadoop cluster will be used only by my department. That time you don't need any restriction, you go for a capacity scheduler. The Hadoop cluster will be used by 10 different departments. How do you ensure that the environment is properly utilized by all the 10 different departments? That time you suggest to go for a fair scheduler. I will create a 10 different pool, department 1, department 2, department 3. Based on your user, you recommend me how many jobs you want. That time you configure and give for a user access. புரியுதா? புரியலன்னா சொல்லுங்க. இது வந்து பண்ணி பார்க்க முடியாது. இது வந்து பெரிய கிளஸ்டர்ல ஒரு 5 ஜாப் ரன் பண்ணும்போது தான் அந்த உங்களுக்கு வந்து அந்த இது தெரியும் ஒர்க் பண்றது. ஓகே, அதுதான் சொல்லினுங்கிறேன் இவ்வளவு நேரம். அதுதான் ஃபேர் ஷெட்யூலர். அதுதான் இவ்வளவு நேரம் சொல்லிட்டு இருக்கேன். உங்களோட அண்டர்ஸ்டாண்டிங் என்ன சொல்லுங்க, நான் கிளாரிஃபை பண்றேன். அது கெப்பாசிட்டி ஷெட்யூலர். அது கெப்பாசிட்டின்னும் போது மேக்ஸிமம் எவ்வளவு கெப்பாசிட்டி இந்த கிளஸ்டர்ல ஓடுன்னு 10ன்னு சொல்லிட்டு வச்சுங்க. உங்க ஜாபே 10மே எடுத்துக்கிச்சுன்னா அவர் ஜாப் சொன்னா கியூல போயிடும். சிம்பிள். ஓகேவா? 2 கான்செப்ட், கெப்பாசிட்டி, ஃபேர் ஷெட்யூலர். கெப்பாசிட்டி மேக்ஸிமம் 10 மேப்பர் தான் ஓடும் இந்த கிளஸ்டர் சொல்லியாச்சுன்னா, நீங்க ரன் பண்ற ஜாப் 10 மேப்பர் எடுத்துக்கிச்சுன்னா அவரது கியூல நிற்கும், ஓடாது. நீங்க ரன் பண்ற ஜாப் வந்து 4 தான் எடுத்ததுன்னா இன்னும் 6 கியூல 6 அலோகேட் இருக்கா, அப்ப அவர் ஜாபும் பேரலா ஓடும். அது கெப்பாசிட்டி. நீங்க ஃபேர்ல போனீங்கன்னா உங்களுக்கு வந்து 3 தான் கொடுத்தனா நீங்க ஒரு டைம்ல 3 மேப்பர் தான் ஓடும். அப்ப 10 பிளாக் வச்சிருந்தாலும் 3 பிளாக் தான் ப்ராசஸ் பண்ணும். அடுத்து ப்ராசஸ் ஆகும். ஃப்ரீ ஆனவனே 3 உங்களுக்கு போனனே உங்களுக்குன்னு ஒரு அலோகேட் பண்ணிடுவேன். இப்போ ஒரு பாக்ஸ்ல உங்களுக்குன்னு ஒரு ஸ்பேஸ் கொடுத்துருவேன், அது உள்ளதான் உங்க ஜாப் ரன் ஆகும். நீங்க அவரது போய் டச் பண்ணும்போது அவரது உங்களுக்கு வந்து டச் பண்ண முடியாது. அதான் ஃபேர் ஷெட்யூலர். புரியுதா? அவுட்புட் எல்லாம் விடுங்க, இந்த ஜாப் புரிஞ்சுதா? அவுட்புட் நீங்க எந்த ஹெச்டிஎஃப்எஸ் பார்த்துக்கிட்டீங்க அங்க போய் ரைட் பண்ணும், அவர் எந்த ஹெச்டிஎஃப்எஸ் பார்த்துக்கிட்டோ அங்க போய் ரைட் பண்ணும். இது அவுட்புட்டுக்கும் இதுக்கு சம்மந்தமே கிடையாது, வெறும் ரிசோர்ஸ் அலோகேஷன் மட்டும்தான். அவுட்புட்ல உங்களுக்கு என்ன டவுட்? இதுல என்ன டவுட் இருக்கு? அவுட்புட்டுக்கும் இதுக்கு சம்மந்தமே கிடையாது. அந்த மெமரி வந்து எவ்வளவு யூஸ் பண்ண போறோன்றதான் கொஸ்டின் மார்க். இப்போ கிளியரா? இன்புட்டுக்கும் சம்மந்தம் கிடையாது, அவுட்புட்டுக்கும் சம்மந்தம் கிடையாது. ஒரு ஆள் எவ்வளவு மெமரி யூஸ் பண்ணலாம் அந்த மிஷின்ல, அதான் இப்போ நம்ம பேசிட்டு இருக்கோம். மாஸ்டர் ஜாப் ட்ராக்கர் லெவல், ஜாப் ட்ராக்கர் லெவல், இது எல்லாமே ஜாப் ட்ராக்கர் லெவல். மேப்ரெட் சைட் எக்ஸாம்பிள் கிளியரா? கிளியராப்பா? ஆ ஆ ஓகே. ஆ அவரு கேட்டதுக்கும் நீங்க கேளுங்க, என்ன டிஃபரன்ஸ்? ரெண்டும் ஒண்ணுதான். நீங்க வேற மாதிரி புஷ்பமாவும் புய்பமும் சொல்லலாம், புஷ்பமும் சொல்லலாம். அதுதான் நீங்க கரெக்டா கேட்கணும். உங்க ஜாப் முடிஞ்சதுன்னா நீங்க எங்க சொல்லுங்க, அங்க போய் ரைட் ஆயிடும்பா. அவர் ஜாப் ஓட்டுறதுக்கும் உங்க ஜாப் ஓட்டுறதுக்கு என்ன டிஃபரன்ஸ்? என்ன பிரச்சனை? ஏன் ஸ்டாப் ஆகி நிக்குது? ஜாபே தான் ஓடாத, கியூ தானே ஆயிருக்கும். ஓன்னா ஜாப் கம்ப்ளீட் ஆக போகுது. புரியுதா? ஓன்னா கம்ப்ளீட் ஆக போகுது ஜாப். புரியுதா? டவுட்னா கிளாரிஃபை பண்ணிங்கப்பா. நீங்க இதுதான் சொல்றேன், 5 வாரத்தை கழிச்சு வந்து கேட்கற கேள்வி இதெல்லாம். இது இது ஃபர்ஸ்ட் டைம்பா. ஜாப் போறது அவுட்புட் ஆகிறதுல எப்ப எடுத்தேன்? கியூலனா ஜாபே ஆரம்பிக்காது. புரியுதா? கியூனா அதான் கியூ. ஓடின்னு இருக்கிறது பேர் கியூ கிடையாது. ஆமா. மூணு மூணுமே ஓடின்னு இருக்கும்பா. சரி இருங்க, நீங்க உங்களுக்கு 3 சொல்லிட்டேன், நீங்க 4 ஜாப் சப்மிட் பண்றீங்க. 3 ஓடிங் போது 4வது உங்களுக்கு கியூல நிக்கும். இவருக்கு 5ன்ற வச்சுங்க, அவரு வந்து 3 தான் கொடுத்தாருன்னா அவருக்கு 2 பெண்டிங்ல இருக்கும். உங்களுதுல 3 முடிஞ்சாதான் அதுல வந்து அலோகேட்டர் வந்து எடுக்கும். கியூல நிக்கனா ஆரம்பிக்கலன்னு அர்த்தம் ஜாப். கியூனா என்னப்பா? ஆமா, 3 ஓடி தானே இருக்கு. 3 முடிஞ்சா ரைட் ஆயிட்டு கியூ ஃப்ரீ பண்ணிட்டோம். புரியுதா? சரி இருங்க வரேன். சரி இருங்க உங்களுக்கு புரியுற மாதிரி சொல்றேன். இல்ல புரியுது புரியுது. வரேன் வரேன், கிளாரிஃபை பண்ணிடலாம். வரேன் வரேன், புரிஞ்சிச்சு, உங்க கேள்வி புரிஞ்சிச்சு. வாங்க இருங்க. வரேன் இருங்க இரு. வெயிட் யாரும் கன்ஃபியூஸ் பண்ணிக்காதீங்கப்பா. See, okay, so 9 I allow 10. Okay, 10 ஸ்லாட் இருக்குப்பா Hadoop கிளஸ்டருக்கு. புரிஞ்சுங்க, 10 ஸ்லாட் இருக்கு. 10 ரேக் இல்ல, 10 மேப்பர் தான் ரன் பண்ண முடியும். நான் செட் பண்றேன், ஏன்னா என் கெப்பாசிட்டி வந்து 16 GB RAM தான் அலோகேட் பண்ணுவேன். அட் அ பாயிண்ட் டைம் 10 பேப்பர் தான் ரன் பண்ண முடியும் ஒரு நோட்லயும். கிளியர்? இப்போ கெப்பாசிட்டி ஷெடியூலர் அப்படின்னா, கெப்பாசிட்டி ஷெடியூலர்ல நான் இந்த லெவலுக்கு போவேனான்னு பார்த்தேன். ஓகே, Arun submitting a job. Okay, it is consuming all the 10. Okay, Muthu Muthu submitting one job, he has to wait. If the 10 is freed, Muthu job will start. Okay. In the capacity schedule itself, if Arun is using only 8, Muthu job will be starting, but you will be using only 2 maps. Okay. When your map is reducing, his map will increase. That is capacity. புரிஞ்சுதா? Fair scheduler. Arun 4. Okay. Muthu 5. Remaining எத்தனை இருக்கு? 1. நான் 1. How I decide, right? Based on the business requirement, I decide this. So you are a very critical department, its usage is very less. Based on that, I will allocate the pool. This is called pool allocation. For a user, I allocated. Now, Arun is submitting a job. Okay. Now, this pool is depends upon 2 things. One is maximum number of map you can run or maximum job you can run. Now come to maximum job, not the mapper. Capacity go to mapper, now jobs. So now you submit 5 job. Okay. This will be queued. At a time, 4 will be running for you, 1 will be queued. When 1 out of 4, 1 is completed, this 4th will be queued. 4th will be running. Queued means it is waiting for the waiting to run. Waiting to run, not running, waiting to run. When your queue is completed, when your 4 job is completed, 1 job is completed. Now 3 will be running. So the 5th will be running. புரிஞ்சுதா? உங்களுக்கு புரியுதா? இதுக்கும் அவுட்புட்டுக்கும் சம்பந்தம் கிடையாது. இப்போ இந்த ஜாப் முடிஞ்சதுன்னா அதோட அவுட்புட் ரைட் பண்ண போகுது. இந்த ஜாப் முடிஞ்சதுன்னா அதோட அவுட்புட் ரைட் பண்ண போகுது. இந்த ஜாப் முடிஞ்சதுன்னா அதோட ரைட் அவுட் பண்ண போகுது. இந்த ஜாப் முடிஞ்சதுன்னா அதோட ரைட் அவுட்புட் ரைட் பண்ண போகுது. எந்த லொகேஷன் குடிக்கணும்? ஈச் அண்ட் எவ்ரிதிங் இஸ் ஜாப். பூல்னு வரும்போது ஜாபுக்கு போயிடுவீங்க. நம்பர் ஆஃப் ஜாப்ஸ். கெப்பாசிட்டின்னு போகும்போது மேக்ஸிமம் நம்பர் ஆஃப் மேப்பர்ஸ் போயிடுவீங்க. பூல் லெவலையும் நம்பர் ஆஃப் மேப்பர்ஸ் சப்மிட் பண்ணலாம். அதேதான். இதுதான் 1/2 மணி நேரமா சொல்லுங்க, 1 மணி நேரமா சொல்லுங்க. புரியுதா? புரிஞ்சுதா? எல்லாம் போய் போட வேணாம். இனிமே நான் இப்படி எக்ஸ்பிளைன் பண்றேன் உங்களுக்கு. சரியா? புரியுதா? ஓகேவா முத்து? நான் கிளியரா இருக்கு. ஓகே. ஃபோல்டர் ஆல்ரெடி எக்ஸிஸ்ட். ஒரு ஜாப் ஆனோடனே ஃபோல்டர் கிரியேட் பண்ணோம்ல, இன்னொரு ஜாப் ஓடும்போது ஃபோல்டர் எக்ஸிஸ்ட் வரப்போகுது. நீங்க என்ன பண்ணுங்க, நீங்க 4 பேர் ஒரு ஜாப் சப்மிட் பண்ணுங்க. ஜாப் லெவல்ல ஃபோல்டர் டெலீட் பண்றது எழுதிடுங்க. டெலீட் பண்ணி ரைட் பண்ணிடுங்க. அதான் யூசர் பேஸ் தானே எல்லாமே. ஓகே, கிளியர் ஆனி அண்ட் ஐயப்பன்? கெப்பாசிட்டி இந்த சென்னா மேப்பர் தான், டேட்டா நோடுக்கு சம்மந்தம் இல்லை. கிளியராப்பா? ஞான் இதுக்கப்புறமும் டவுட் வரக்கூடாதுப்பா. வேற டவுட்டா? ரன் பண்ணுவோம், கடைசியாக ரன் பண்ணுவோம். இன்னும் நிறைய இருக்கு முடிக்கிறதுக்கு, முடிச்சு கடைசி ரன். கெப்பாசிட்டிக்கு வரும்போது மேப்பர் செட் எக்ஸாம்பிள், டேட்டா நோடு வரும்போது job, if anything comes to the job level, mapper set XML. Anything comes to the data level, it is HDF set XML. Clear, Arun? கேளுங்க பரவாயில்ல கேளுங்க. செட்டப்னா எந்த செட்டப்? ஒன்றுமே அதெல்லாம் டிஃப்ரென்ஸ் ஒன்றுமே கிடையாது. அதான் நான் சொல்கிறேன், நீங்கள் ஜாப் ரன் பண்ண சொல்கிறாரு, ஜாப் ரன் பண்ணி காமிங்கன்றாரு. ஒன்றும் இல்லை, அதே ஜாப் தான் இங்கே, வேற ஒன்றுமே கிடையாது. அதே கோடு எல்லாம் அதே தான், எதுவும் மாற்ற தேவையில்ல. அப்படியே ரன் பண்ணுங்க, எங்கே புது டேட்டா இருக்கோ அந்த இடத்துல பாயிண்ட் பண்ணுங்க, அவ்வளோதான். ரன் பண்ணி காமிக்கிறேன். அது ஒரு 15 மினிட்ஸ் ஆகும், அது நம்ம இது முடிச்சிடும், முடிச்சு ரன் பண்ணி. சரி, ரன் ஆகும்போது எப்படின்னா பார்த்துருவோம், சரியா? So Hadoop HDFS federation setup, right now this is not that much important. Okay, so federation setup, right? How well you are using your HDFS? Okay, so restarting your secondary name node automatically and recovering the failover of the primary name node, that's called HDFS federation. Okay, so this concept 2 years before federation they used to say, now it is not used, federation concepts. Okay, so federation concept, right? So start your first node, then secondary name node, start the secondary name node, automatic failover of both nodes. So this is similar like we said, right? Manually you copy the FS image in edit lock and start the Hadoop, right? So that is a manual step. So HDFS federation, they have introduced a new version that is like automatically recovering the secondary name node. That is the federation setup. But this is theoretically it is proved, but practically manually only you have to do it. Okay, so that is like you will change the transition to active, right? From moving from your current primary to secondary node active, that is called federation. Okay, okay, securing your Hadoop cluster, this is very much important. Okay, so by default right now we install under HD user under slash, like that we install, right? In real time you will install under OPT, shared location only you will install, so that only the root user has an access, everyone can go and access that. So right now only HD user can access this machine, no one can access this Hadoop cluster. Clear? Clear? So when you install under OPT, you have multiple user can access that Hadoop. So how do you do it? There is two ways you can do it. Okay, one is user based and as well as AD active directory group based. User based means each and every time you have to add a user to a group, which means, for example, you add a group called Hadoop and then you have to add a user to that group and you have to give a password. Sometimes if the user forgets the password, he has to come back to the administrator to ask for a reset of a password, because the user cannot change the password. Okay, that's a big job. That is a default security mechanism, and you can set at the group level. When you set at the group level, what happens? So you see HD user, so all the HD user only can access this. Okay, so now when you add one more user called HD user 1, he will be creating another folder called input HD user 1. So any data which is under HD user 1 only he can access, any data under HD user only HD user can access. So that how do you do it, right? Hadoop FS, so change mode, change one, change group, right? So here you can see change mode owner, that is a user or a group you can give. Okay, so for a Hadoop system you have 10 users means 10 users can have a separate folder and they can store and process only in the data. Only that user can access the data. That's the meaning of it. This is nothing to do with the security of Hadoop. It is based on the Linux file system only, because it's a Linux system. So as default, the group or a user you manage with the Linux and add the HDFS folder to that particular user or a group. Only that user can read or write the data to that folder. Clear? 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 இது வந்து நார்மல். இது வந்து ஒரு யூசர் தான் இருக்காங்க. ஒரு யூசர் தான். முத்தி அதை கண்டுபிடிக்க வராது. சரி. ஆமா ஆமா, அதான் கரெக்ட் தானே? இதுல என்ன டவுட்? இப்ப தானே சொன்னேன் நான். Hadoop யூசர்ன்றது ரூட். யூசருக்கு வந்து டிஃப்ரெண்ட் யூசர்ஸ் கொடுத்துருவீங்க. அதனால தான் Hadoop வந்து நம்ம HD யூசர் உள்ள இன்ஸ்டால் பண்ணாதான் உங்களுக்கு இப்படி தெரியுது. ரூட் யூசர்ல இன்ஸ்டால் பண்ணீங்கன்னா அங்க ரூட்னு காமிக்கும். அப்ப அந்த ஃபோல்டரை ரூட் யூசர் தவிர வேற ஆக்சஸ் பண்ண முடியாது. கிளியரா? அப்போ புதுசா 10 யூசர்ஸ் வந்தாங்கன்னா ரஞ்சித் திட்ட போறாரு, எல்லாம் தமிழ்ல பேசிக்கிறேன். ஆன்லைன்ல பட் ரெக்கார்டிங் பார்த்தா. ஓகே. Now you see it. Right now you install Hadoop under root user. Root user will not store the data or anything. He will only manage the Hadoop cluster. That's all. If anyone wants an access to Hadoop cluster, you will add the user as a Linux user. While adding the user, administrator will create a parent folder. Administrator will create a parent folder /HR, and you will add a group called HR. Add the 10 user of HR to that HR group, and he will change the ownership of the HR folder of HDFS to that group. So only HR users can access that folder. Write the data, read the data, anything. Clear? 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 புரிஞ்சுதாப்பா? Annie and Ivan? Clear? Okay. So that is with the user level. Okay. The other way of secure authentication at the Kerberos level. Kerberos level is a single sign-on system. Single sign-on system means a user need not to be added to the machine. A user has to be added to the group level where you don't need to give the password. The password you are logging in for your computer of Windows, the same username and password you can use it for Linux. That is called Kerberos single sign-on authentication. Whenever you change the password globally, the password will be reflected across the machine. So this is how in real time the system will be managed. Why? Because if you give 100 user comes daily and say password is not working, change the password. All those things, it is a big headache for administration. So you have to do a Kerberos. To do a Kerberos, you cannot do in your ear. You have to have an Active Directory group settings, and then your machine has to work on the single sign-on. Active Directory means domain configuration. Active Directory in Office it will be muthu@capgemini.com. That is Active Directory. Okay. So your users will be across the domain. All the machine will know Muthu. That is Active Directory sync up. Clear? Clear? Clear, ba? Production will be using this. But there are infrastructures where they will say Active Directory we cannot set up this box. Go with the user base. Only 10 user will be available. That time you don't need. So that time you have to set in core set XML Kerberos equal to true, authorization is equal to true. In HDFS you have to enable this. Here where you set the fully qualified DNS name. Where you? I'll show you that. This is a key tab file. Okay. So this is a key tab file. We'll have that active directory information. Okay. Key tab file will have the active directory information. So what happens this, right? Name node.key tab file means always it will refresh the security credential from this key tab file. So you have to speak to your DNS administrator to extract the key tab file. For each and every active directory group, there will be a key tab file. Active directory group means as a whole, they will create an active directory called Hadoop user. If anyone wants an access, they will add to the active directory group. By default, it will access the user to this machine. Clear? Simple. உங்க மெயில் குரூப் இருக்குல்ல, அந்த மாதிரி ஒரு மெயில் குரூப் ஒன்று இருக்கும். குளோபலா அந்த ஆக்டிவ் டைரக்டரி குரூப் இருக்கும். ஸோ அந்த குரூப் வந்து இந்த கீ டேபுக்கு மேப் பண்ணுவாங்க. மேப் பண்ணியாச்சுன்னா எந்த யூசர் போய் நீங்க அதில் ஆட் பண்ணாலும் தே கேன் ஆக்சஸ் திஸ் மிஷின். கிளியரா? ஸோ என்னப்பா ஆக்டிவ் டைரக்டரி அது ஒரு நெட்வொர்க் கான்ஃபிகரேஷன். ஓகேவா? நீங்க சொல்ற ஆக்டிவ் டைரக்டரி விண்டோஸ்ல இருக்க ஆக்டிவ் டைரக்டரி, அது வந்து விண்டோஸோட டெர்மினாலஜி. அது ஆக்டிவ் டைரக்டரி டொமைன் கான்ஃபிகரேஷன். ஏசியா பசிபிக் இருக்குல்ல, ஏசியா பசிபிக்னா கேப்ஜோன் ஏசியா பசிபிக் இல்ல, அது ஒரு டொமைன். அந்த டொமைன் உள்ள ஐக்கியான்றது ஒரு ஆக்டிவ் டைரக்டரி குரூப். இப்போ உங்க ப்ராஜெக்ட் யாரா அக்சஸ் வேணும்னு வச்சுக்கோங்க, ஐக்கியா குரூப்ல போய் ஆட் பண்ணாங்கன்னா ஐக்கியா இருக்கிற சிஸ்டம்க்கு எல்லாம் அக்சஸ் வரும். அதுதான் ஆக்டிவ் டைரக்டரி. அதுக்கு தான் கீ டாப் ஃபைல் ஜென்ரேட் பண்ணிட்டு இந்த இடத்துல கெர்பரோஸ் பிரின்சிபல் யூ வில் கெட் ஃப்ரம் தி அட்மினிஸ்ட்ரேட்டர் பிரின்சிபல் கிடைக்கும். அதுக்கப்புறம் குவாலிஃபைட் டொமைன் நேம் கொடுப்பீங்க, அவ்வளவுதான். அதே மாதிரி செகண்டரி நேம் நோடுக்கு. சொல்லுங்க. சரி, கரெக்ட். சரி, கரெக்ட். அது நெட்வொர்க் ஆக்டிவ் டைரக்டரி. இந்த நெட்வொர்க் இல்ல, அவர் புரிஞ்சிச்சு எனக்கு, அவர் கொஸ்டின் புரிஞ்சிச்சு. ஒரு ஆக்டிவ் டைரக்டரி வந்து விண்டோஸ்ல ஆக்டிவ் டைரக்டரி ஒரு கான்செப்ட் இருக்கு. நீங்க இப்ப கண்ட்ரோல் பேனல்ல போனீங்கன்னா ஆக்டிவ் டைரக்டரி இருக்கும், அது கிடையாது. இது நெட்வொர்க்ல ஒரு ஒரு டிஎன்எஸ் நேமுக்கும் ஒரு ஒரு ஆக்டிவ் டைரக்டரி இருக்கும். அந்த ஆக்டிவ் டைரக்டரி என்னன்னா அந்த ஆக்டிவ் டைரக்டரி பாயிண்டிங் டு விச் மிஷின். ஆமா, கரெக்ட். ஓகேவா? ஸோ இந்த ரெண்டு பிரின்சிபல் நேம் யூ வில் கெட் ஃப்ரம் தி அட்மினிஸ்ட்ரேட்டர். Key tab file will have a principal name. Okay, when you add this, so any user belonging to that group will have an access to this machine. That's a single sign on. Okay, similarly you have to do for secondary name node as well. Okay, Abba, Annie and Ayappan. Normal username password, add the user to the group, that's all. Any group you can add your own group. Okay, clear? So according to Muthu request, we'll run a job now. அதான் ஆக்டிவ் டைரக்டரி குரூப். வாங்க. நாளைக்கு சொல்றேன். ஒரு நிமிஷம். Okay. So now I'm going to run this program, Hadoop training. Okay. பார்க்க போறேன் இன்னைக்கு. உண்மையில அது 5 நிமிஷம் தான். நீங்க இந்த மாதிரி கேள்வி கேட்டீங்கன்னா 6 மாசம்லாம் முடிக்க முடியாது. Okay, Hadoop training, and I have a sorting driver where I have the input path of HDFS output path. Okay. So now dot okay, input slash txns output slash output folder does not exist. Okay, see here, Muthu, paranga. So submitting the job. Okay, so job is being submitted. So go to the job tracker. So total 10 blocks it is there, right? So number of nodes 4, cluster, job it is submitting. So running map task this. So job ID, number of map total 10 mapper it is processing, but we have 4 nodes only. Clear? So map is 8.5. So similarly you can go to the task tracker. So go to the task tracker. One dot 17 only, right? 22. Okay. You see, task tracker is running. Inside that, we are in a job tracker. Parallelly reduce is running. Can you see that? This is 80% only completed. Parallelly reducer is running. But the only the thing, right? The number of reducers in this case 2 is used. Clear? Not 10. The reducer is depends upon the number of bytes a reduce can process. If the number of bytes it increase, automatically the number of reducer will be decided. Clear? 10 blocks, 10 mapper, 8 completed, 2 reducer. Huh? 5% of reduce தான் ஆரம்பிச்சிருக்கு. Depends on availability of data. Okay. Okay. 10 map completed. If you see here, 3 job failed. Okay. 3 job failed. Okay. 411 data node. But it was resubmitted again and processed in another nodes. Got it? 10 was submitted, 3 was failed, but it will again submit to another node and it failed. If you see the error details of this, file system closed. Okay. What happens in this case? While reading the data, okay, here I use a split condition, right? You remember I have concatenated a data. That time it will come a new line. So that time it's trying to split that empty line. It might throw an exception over here. So that block, it will have an issue. So that's why it is processing in another block. So in any exception comes, so now it is processed this many records. So we have did with 7 times the file. So 7 million records. Clear? That is the map output number of records. Reduce output records will be 15 because we are doing a group of the profession or some other groups. Clear? So if you go and see the output, happy Vamutha. அந்த ப்ரோக்ராம் ரன் பண்ணா இதுல அவுட்புட் வராது. Now you see டேட்டா சின்னதுல இது ரன் பண்ணி காமிக்கிறது, இது கிளஸ்டர் பெருசு, மல்டிபிள் பிளாக்ஸுக்கு தான் காமிக்கிறேன். உங்க சின்ன டேட்டா ரன் பண்ணா அதுல ரன் பண்றது ஒன்று தான், சிங்கிள் நோட்ல ரன் பண்றது ஒன்று தான். கரெக்டுப்பா. அது ரன் பண்ணாலும் உங்களுக்கு டிஃபரன்ஸ் தெரியாதுன்ற. சின்ன டேட்டா இல்ல அது. பண்ணலாம், அதே ஜார் தான் நானும் ரன் பண்ணேன் இப்போ. ஒன்றும் டிஃபரன்ஸ் இல்லையே, போன வருஷத்துல ரன் பண்ணதும். ஓகே வரேன் இருங்க. இப்போ now you see two files it is created, part-1 and part-0. Now you go to this output, transactions, replication factor 3. Okay, for the block also it will maintain the replication factor 3. The data is 600 MB. Okay, so but why it is writing two file? Size is 0.25 KB only, right? Huh? Two reducers. Okay, two reducer, two different nodes. So if you go here, complete two reducer it is pointing. If you go here 6 counters, if you click this, okay, data node 2, okay, but still if you do this, all the logs is pointing from the job tracker only. 4, clear? One job is killed in data node 1, one reducer. Okay, clear on this? That's the reason you are having 2. Now the same thing if you do with Hadoop fs minus get merge. மெர்ஜ் பண்ணிட்டு காமிக்கிறேன். Okay, so you have given a file, you have to give folder. Copy to local na தான் file. யாரும் வீடியோ பார்க்கறதே கிடையாது. Okay, clear? It will take the output from 2 file and give it as a 1 file. So if you go to how many records here? 15. We got 15 output, right, in reduce. So first file will have some output, second file will have some output. So first file we have 4 records, second file will have 11 records. 3 4 5 6 7 8 9 10 11. Clear அப்பா? புரிஞ்சுதா? That's a get merge. Get merge you can copy to another HDFS as well. So we did a get merge. All the files under that folder it is merged and give us a single output.csv. When you want to give that to a business, when you transform with MapReduce and you got analyzed data, that you have to feed it to end customer as Excel file or CSV file for the reporting purpose. You do a get merge, export and give to them. Sequence. Okay, so as a shell script, trigger a job, get the output, get the output CSV, send an email to customer. That's a workflow. With the workflow we have to do it. Clear? No, Hadoop, what Boozy will do that, but externally you can use the shell script with any Tidal or Control M, any BMC tool you can use it. Clear? Clear, Muthu? எங்க என்ன பார்த்துட்டு இருக்கீங்க? புரியுதா? உங்க ஜாப் ரன் பண்ணல ஏன் அப்படின்னு நீங்க வருத்தப்பட்டீங்கன்னா ரீசன் வந்து என்னன்னா உங்க ஜாப் சின்ன டேட்டா காப்பி பண்ணீங்கன்னா 64 MB கம்மியா தான் இருக்கும். அப்போ ஒரு மேப்பர் தான் ரன் ஆகும். The purpose of multinode cluster you will not understand. ரன் பண்ணுங்க, போயிட்டு ஈவினிங் போயிட்டு ரன் பண்ணி பாருங்க. சரியா? பண்ணுங்க, ஒன்றும் ஆகாது. திருப்பி செட் பண்ணீங்க Hadoop. So now you see it. Hadoop, wait, Hadoop job hyphen list all if you give, it will set priority will be normal. It was completed. The status running succeeded. It is succeeded. When you submit, it will be running. Clear? Clear? Everyone is clear? Annie and Ayyappan, is it clear? Any doubt on this? Okay. So before we go on to the next Hadoop generation 2, next important thing is called compression. Okay. Compression, I will say you the configuration. It is straightforward, no difference. Okay. So why we go for compression, right? When we store, now we stored 600 GB of data, 600 MB of data. If you store like this 10 GB of data, same 10 GB disk space will be occupying. If you use a compression, 600 MB will be reduced to 50 MB of data. On the fly, Hadoop has a capacity to process the compressed data. Got it? On the fly, Hadoop has a compressed medium to process the data. So that's how you effectively utilize your cluster. Clear? When you use a compressed mechanism, you remember I opened to the block and we are seeing the data. When you use a compressed mechanism, you cannot see that. Okay? Only via Hadoop only you can see it. That is the basic understanding of compression. So what are the different compression available, right? ZZip, BZip, LZO. ZZip, BZip is straightforward. ZZip, BZip is straightforward. LZO is we have to do a lot of configuration to Hadoop. All the steps is available in this PDF. Okay. So splittable, yes means splittable means when you do a storage of the data, it is splittable. That is like 64 MB, 64 MB is splittable. And while reading also, Hadoop knows the next available thing. So for example, when you use a new line character, it is knows that the splitting will be next new line character. Similarly, when you are processing this particular zip code, it is not what will be the continuity of a next zip code, next zip file. Okay, you cannot use tar all those things because it does not understand a tar file. Only this 2 compression, 3 compression only you can use it. Clear? Clear? Performance wise, no, it is for the storage. Performance wise as well, while reading that block alone, it will uncompress and process. It will take time. It is majorly for the storage. Pay for it. Okay. So in your core site XML, Okay. In core site XML, you have to go and specify io.compression codec is equal to this. Okay. Similarly, in mapper site XML, you have to specify compression type is equal to zip. Jar not configuration file, property file. That's all. Okay. Compressed. Okay. So if you want to have any file to convert to zzip file name, it will be converted to zzip. If you want to test, only in the program, right? There is no change with the mapper, reducer, and there is no change to the program as well. You don't need to mention any file formats for zzip. Okay. Framework will capture the codec information from the configuration file, automatically will process. Okay. Similarly for bzip, same thing, you have to specify bzip. No change, everything is bzip. So if you want to convert any file to bzip file name, the extension will be bz2. Okay. Hadoop. By default, this two codec will be coming with Hadoop. The third codec was what you have to install separately. So everything is same MapReduce program will work, no change. Only in the LZO, you have to install the LZO separate compression level. Sudo install LZO you have to mention. So this will install the LZO in your machine, and you have to copy that LZO to your Hadoop library. Under lib, you have to copy that jar. Okay. So after you are copying, you have to build the Hadoop. After that, everything is same. Only in that configuration, you have to put LZO codec. LZO codec. Similarly, in your MapReduce LZ codec. But in the MapReduce program, you have to specify the input format is LZ2 text input format. That's all. No other change. Okay. So bzip, lzip, gzip. 3 zip format it supports. It's very simple. Just you have to configure, run it. Okay. And yes. So if for example you have a size of a cluster 10 node, and each and every one stores 1 GB text file, right? So we want to effectively manage the storage system. That time the zip format is used. That compression it will not, only for text file only it will. More text you can go for compressed. And how well you can manage your cluster as well. More zipped thing, less size it will occupy, obviously. Okay. And as well as just to unzip and okay. So why you cannot go with this, right? Means when you store a data, all the data what you store for HR should be of same data type only, because that's how you write your MapReduce program. You write a MapReduce program for a certain pattern of a data. If a pattern consists an XML file, text file, image file, audio file, we cannot process with the MapReduce. The transformation you have to know only by knowing your data formats. Clear? Clear? Okay. So this one, H catalog, I have already placed the steps what to do. You saw that, right? And complex data type as well I have placed. Okay. It's only the collections you have to change. I have placed a complex as well. There will be in the root folder itself 5.txt file will be there. The root folder of Google Drive. Okay. That has the complex queries. These two things. H catalog only you have to register the H catalog in PIC. That's all. and you have to start a thrift server. It will work. Okay. Apart from that, we will see Hadoop 2.0 post lunch. Is it clear? With that, we are completing Hadoop administration, and we'll be completing Hadoop generation 2 after lunch. Hadoop architecture 2.0 we'll be seeing. Okay. Working everything is same. Only the way how the job we have seen capacity schedule, fair schedule, right? There will be different. That's all. Mahood. Mahood are not there. Mavian. Mahood not a part of the session. That is data science class. Okay. Yarn only generation 2. Mahood is a separate machine learning which will use Hadoop infrastructure. Okay. Clear? Clear on this? Okay. Okay. So we'll go for 2 o'clock. Mavian will complete now. Okay. So Apache Mavian. Okay. So right now what we do, right? Each and every time when we add a jar, while we are exporting only the class path, it will go. It will not take the dependency libraries. For example, if you have third-party libraries, for example, I'm parsing a CSV, I'm parsing an image file. That time we needed third-party jars to be added. Okay. So while doing that, either you can do in two ways. One is packaging the dependency and running. Other way is like making the jar available across the node. To make the jar available across the nodes, the first way is to set the class path for Hadoop. Okay. So you copy the jar to any location, dependency jar, and you set Hadoop user class path. Hadoop class path is equal to new jar and register the class path. So which means the jar will be made available to all the Hadoop. Okay. Hadoop will take care of the dependency jars to be available to all the nodes. That is setting under Hadoop class path. Clear on this? Clear on this? Okay, this is with the class path. So for Pigo as well, for H catalog, I have set the class path for Pig. This is the class path for Hadoop. Okay. The next way is with the Apache Mavian. For Mavian, you have to download the okay. So you have to download Apache Mavian and configure your environment. See, now I have downloaded Apache Mavian. Okay. So this is my Apache Mavian. This is my Apache Mavian. I have to configure my environment variables, which is called M2OM or Mavian OM as environment variables. So M2OM and Mavian OM, you have to configure the location. Okay, environment variables. After configuring environment variables, similarly, you have to also configure your M2OM under your Mavian. You have to configure. Okay, it automatically will come when you install a Mavian. So you can install the Mavian Yelp Eclipse Marketplace Mavian. It will automatically install the Mavian. So what is Mavian? It is for packaging your jars, and you don't need to each and every time you download the jar and add it. So Mavian is a central repository for all the Java jars. Okay, all the Java jars, Mavian as a central repository. Just you have to tell what version you want. So if you go to Mavian, I want to download and add so CSV parser is a jar I want. This is my Mavian repository. In the Mavian repository, you will see a Mavian group ID artifact version. So this is the dependency jar. If you add, when you build a project, it will go ahead and download this respective jar and stored under the location called M2. Here you see a color called M2. It will download and all the project will references here. When you package, it will package all the jar and give us a packaged jar. Okay. So that is the main aim of Mavian. So for example, you don't need to download and add a reference to that. Nothing you don't need to do. So when you create a Mavian project, when you install Mavian, start new, other, go to Mavian project. In the Mavian project, use default workspace. You can use a create simple project. Select this one. So what is the default of that, right? Each and every project type has a skeleton. So if you use that, it will have a default skeleton. So in this case, you specify your group ID as com.test. Okay, com.1.0.1. Okay, name will be testing Mavian. When you do this, it will create a Mavian project. After creating a Mavian project, you will see a file called pom.xml. Oh, shit. Okay. So now, so this is that artifact ID. You have to give the name, proper name. Okay. So now it is created a project with 1.0.1 version. So in this you can see the form file. Okay. The form file, when you add this, okay, very slow. So here this is the com.test, the artifact I have given like this. Okay. If you want to add any dependencies for your project, go to dependency. You can add the dependency. You have seen the group ID artifact version there, right? Same you have to give and okay. Okay, that will add the jar. After all adding the jar, right, you have to add a, either you can go ahead and change over here like this. See here like this, it will add all the dependencies. Can you see here all the dependencies? And in the POM site XML, it will be reflecting like this. So in the POM site XML, it will add a dependencies like all the dependencies for your project. If you want to change your repository apart from the Maven repository, any other repository also you can have it. Okay. So after all the dependencies, right, there will be one mechanism called a package. Plugin dependencies single. Okay. Plugin with Maven assembly plugin package. Okay, this you have to paste it under that XML file. So once you paste it, if you issue a command of mvn package, it will give two versions of jars. One is with the dependencies and another is without dependencies. That jar you can put it in the Hadoop environment and run it. Rest of the program are same. Only the way you add the dependency and the packaging will be different. So these are the commands. I'll share this. Clean dependency, copy dependency package means all the dependency it will copy and package it. Only compile means it will compile the project. So now Maven compile, everything will be Maven. So now, so Storm or Spark. So this is the POM file. So when you package, it will have two jars. One is with the dependencies, another is without dependencies. So it's very simple. You go to the, while packaging, right? You go to the command line. mvn compile, it will compile. Okay. It will download all the jar from repository and it will place it. mvn package means you have to go to the directory where the POM file is there. mvn package, it will package. That's all. That is how you can transfer the jar to the Hadoop. So similarly, we have ant build SBT build, like this different build mechanisms are available, and the artifacts and the group ID for each and every build mechanism you can see here. Grape, SBT, IV is called ant. You have to use the respective details of that particular jar. That is versioning with GitHub, GitHub, GitHub and Bitbucket. That will have the versioning. Yes. So you will give the latest version there, right? Version 2.0. Here, version 2. That is GitHub and SVN. That is nothing to do with Mavian. This all is a package building. That's all. Nothing to do version. Okay. Clear? That is normal Java, GitHub, everything will come. That is normal package sourcing. Nothing to do with Hadoop. This also nothing to do with Hadoop. This is normal Java. That's all. Oh, any that is normal Java. That's what this all nothing to do with Hadoop. This is normal Java project or any .NET project. This will apply. Okay. Clear on that? What else is pending? Generation 2 is pending. Overall architecture is pending. Overall integration is pending. Okay. So that we'll see after lunch. Okay, we'll go for lunch. What time will we be back? Annie and Ayaban? 2:45. Is it fine?
Okay, bro,
Quick,
fine.
Annie, quick yes or no, please. You there, Annie? Okay, we'll be back at 2:45. So now what happens? So this is the data we have, HDFS. Okay. On top of HDFS only, MapReduce, everything is running like IUPIG, everything. Okay. So what happens in this case? So now when MapReduce is running, okay, it will consume 85% of a memory by default. Okay. 85% of a memory it will consume. So if you have 1000 nodes, you cannot use that Hadoop MapReduce, Hadoop for any other purpose. So 1000 node machine you have invested, but 1000 node can be only used by Hadoop alone. It cannot be used for any other purpose. That is called generation 1. Generation 1 it is said as it is a non-enterprise version as well. So what is an enterprise version? Enterprise means where it has a medium where you can scale and lot of other applications can be running on the same infrastructure. That's what we call as enterprise view. So in this case, what happens when you run job, when Hadoop running, you are having a 2400 square feet, for example, an house, okay, and you are giving a rent for a bachelor for 600 square feet. So he is getting married, kids are coming, the expansion of 600 square feet to occupation of another 600 square feet he can do very easily, considering his strength, where the house owner does not have a control of the extension of occupation. How much he is occupying he cannot control. As and when he require he keeps on occupying and expanding that. Similarly, where in the case of Hadoop generation 1, when you are submitting the MapReduce job, even though you control with pool and capacity scheduler and fare scheduler, all those concept, the expansion of the memory you can only control to the job level. Okay, in resource to the memory utilization, CPU, disk space utilization, you have to do a lot of configuration. On top of that, the same machine cannot be used for multiple purpose. I cannot have Hadoop one machine, another software in another machine. So another software requires a 1000 node cluster. For that another infrastructure I cannot set up. How well I can utilize the same machine for multiple purposes? So that's where the new framework was come into the picture called YARN. It is called yet another resource negotiator. Yet another resource negotiator. Negotiator. Okay. So now I'm using this Hadoop cluster. So HDFS is by default. That's for storage. Only we are dealing with the processing. I can run a MapReduce job. The same cluster I can use for Spark. The same cluster I can use for Storm. The same cluster I can use for Kafka. Okay. The same cluster I can use for Hoot. So likewise, the same infrastructure I can use for multiple purposes. So when a MapReduce is running, it will be allocating only a certain amount of space, memory, CPU for the MapReduce job. So overutilization will not happen. Around 100%, 20% of memory only will be used for each and everything. Okay. Rest of the memory will be used for different purposes. So the same Hadoop cluster you can use for different purposes. So MapReduce is called IO based operation. Okay. Spark is called in-memory based computation. Same data in HDFS, but it will not use MapReduce concept. It will use a RDD format called a resilient distributed dataset. Resilient distributed dataset in memory computation. All the computation will be doing in the memory. That is Spark. In memory computation. So for example, MapReduce, right? You remember we configure local.mapred1, which means after processing it will write to the disk and again you read from the disk. But Spark, it will store in memory, compute, and finally only it will store in disk. That is in memory computation. Okay. Storm, real time data streaming processing. It does not have any storage engine. On the fly the data comes, it will compute and it will give the result set. There is no storage engine in the Storm. That is Storm. It is not a guaranteed message processing system. So for example, stock monitoring, you see the stock is keeps on changing. That is a real time data. As and when the data comes, it will process. That is Storm. Okay. So Kafka is a message queuing system. It works based upon produce and consume mechanism. Produce and consume. Yeah, all the message you get the data from different producers like stock exchange, gold exchange. Likewise, all the data you get to one place, and whoever require data, you can consume the data. That is produce and consume mechanism. Mahout is a machine learning mechanism applying machine learning on the big data. That is Mahout. Machine learning algorithms on the big data. That is Mahout. So to make all this thing, everything is a distributed processing only. It requires a cluster like Hadoop. Okay. So with the help of Yarn generation 2, you can install everything on the same cluster and everything can run on the same machine. That's called Yarn, yet another resource negotiator. How Hadoop is converted to Yarn is what we are going to see now. Clear on this? So we have seen the overview of Kafka, Mahout, Spark, Storm, right? And one more thing we have Redis. It's a key value store. Okay. Redis. Yarn. So that's what we are going to see now. By default, Hadoop comes with Yarn. There is no change to the HDFS. There is only the change to how the processing will happen. Clear? Key value store. It's a distributed. That means Redis will consume certain memory. Right? So distributed cluster. So 1000 node if you use as well, for Redis it will give one memory. Okay. Clear? Clear on this? So now this is the architecture for generation 2. So what happens now? You have the job tracker, right? Job tracker. That is replaced with resource manager. Job tracker will be replaced with resource manager. And task tracker is replaced with node manager. Okay. Resource manager. Task tracker replaced with node manager. Okay. Task tracker replaced with node manager. Okay. So the storage of name node, data node remains same. Only the processing of job tracker, task tracker is changed. Why we mainly go for this, right? Okay. If 100 jobs submitted and it's been keep on running, okay, this will be entry question. In generation 1, job tracker is failed. What will happen to the 100 job? 100 job will be failed. You have to resubmit the job. And all the jobs is communicating to one job tracker server. The overload to the job tracker is very high. In terms of name node as a single point of failure, similarly, the job tracker is a single point of failure for all the jobs. Okay. So now to overcome this problem, we go for a yarn based management. One is called resource manager and is called node manager. So here the arrow is what the key here. So you have to concentrate clearly on the arrows, color code and the arrows. So now the resource manager, internally it will have two concepts called application manager and scheduler. Application manager and scheduler. Whenever you submit any job, blue color job, you submit it, the scheduler first allocates the CPU memory utilization. It is like a container. So 100% of container in which 20% it will allocate. Okay. When the scheduler allocates a container, it will allocate a container in all the nodes where are the data exist. 1, 2, 3 container it is allocated. So out of this entire space, only it is allocating 20% for the job, blue job. And the blue job will be running in 3 containers. Container is equal to small box, you think, in that only it has to run everything. Out of the 3 container, one will act as a application master. One will act as a application master. So what happens? All the MapReduce jobs, here we call as application, not jobs. All the application which is running on each container will communicate to the application master. You see this blue color communicating to the application master, and that will take the status of the each and every application which is running on each and every node. Okay. So this application master, in case if the resource allocated initially was not sufficient for to process, the application master will request the resource manager for more resource. The application not able to see the Excel. So Annie, can you see my Excel? Is the Excel is visible?
Yes, Krishna.
So Ayyappan, can you check at your end? It is visible. Okay. So now the application manager will look after the available resources on the cluster and reallocate the additional resources. Okay. Where it will get the additional information, what is the resource available? The node manager will keep on updating the available resources on the server. Okay. Based on that, the application manager will reallocate new resources. What is the connection between application master and application manager? Application manager, it will only get the details about the job. The control of the job will not happen in application manager. You got it? So even the resource manager failed as well, there will not be a failure to the jobs which is running, because the jobs is being managed by the application master. So now the control is like you manage your own job. I will not have a master, but someone requests me what is the status of the job. I will connect to all the application master and get the status and show to the client. Clear? Clear on this? Okay. So now the node manager will about reply on the status of data node 1, what is the application running, how much container is used, what are the containers free, all the detail it will send to the node manager. Node manager will send to the resource manager. If any new job comes, resource manager will check the remaining space or resources, and it will tell the scheduler to allocate respectively to that. Clear? Will tell the scheduler to respectively allocate to that. Clear on this? Clear on this? Okay. Now, parallelly, if you submit a shell script or a hive job, the resource will be allocated accordingly. For green job, separate container will be utilized. For maroon job, only 2 containers are used. Only within that the job will run. So remaining space will be available. You can use the space for any other purpose. Clear on the flow? Right. 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 But you cannot use the cluster for any other purpose. Storm, yawn. So again for Spark you have to build a 1000 node cluster. For Spark you have to build 1000 node. Storm you have to build 1000 node. So enterprise solution. Enterprise. So previously MapReduce itself will utilize all the resources. Now the resources can be used across multiple applications. So if you look at this diagram, so previously it can use only by MapReduce. Now a single system you can use for multiple application. To convert that to a, because when you convert to yarn, the control has to be given in terms of MapReduce jobs as well. You cannot use the same MapReduce control mechanism with all other applications like Spark Storm, because MapReduce by default designed to consume 85% of memory. That's the reason it has changed from the architecture of job tracker, task tracker to resource manager and node manager. Clear? That is generation 2. So that's the reason generation 2 is called enterprise solution. Clear, Lawrence? 4 node manager. That's why I clearly said task tracker is equal to node manager, job tracker is equal to resource manager. Mm. See, it's very simple. Task tracker is equal to node manager. There is no change to that. Job tracker is equal to resource manager. When you submit the job, depends upon the data availability, it will submit to all the task tracker. That is a concept. Same applies here. There is no change to the allocation at all. The only thing, right, before allocating a resource to a job, the resource manager will allocate a respective memory and CPU to the job. Within the job, it has to operate. To monitor that within the thing it is operating or not, that will be taken care by node manager. Got it? Clear? இப்பயும் அப்படிதான் ரன் ஆகும். 3 ஜாப் ஓடுது இதுல. ப்ளூ ஜாப், கிரீன் ஜாப், ரெட் ஜாப் வச்சுங்க. ரெண்டுத்துல ஓடுது. ரெண்டுத்துல ஓடுதுன்னா ரெண்டுத்துல தான் டேட்டா இருக்குன்னு அர்த்தம். புரியுதா? புரியலையா? உங்க கேள்வி வந்து ஏன் அதுல ரெட் வந்து ஏன் ரெண்டுத்துல மட்டும் காமிக்குதுன்ற கேள்வியா? மூணுத்துக்கும் அப்ளிகேஷன் மாஸ்டர் இருக்கு. அவங்கவுங்க ஜாப் அவங்கவுங்க கண்ட்ரோல் பண்ணிக்கங்க. சரியா? மூணு தான் ரன் ஆகுது. மூணுத்துல ஒன்னு அப்ளிகேஷன் மாஸ்டர் ஆக்ட் ஆகிக்கும். மூணுமே கண்டெய்னர் தான்பா. கண்டெய்னர்ல ஒன்னு மாஸ்டரா ஆக்ட் ஆகுனா ஒன்னு எல்லாத்துக்கும் ரெஸ்பான்சிபிலிட்டி எடுத்துக்கும். இப்போ ஒரு அப்ளிகேஷன் மாஸ்டர் இப்போ டேட்டா நோட் 1ல அப்ளிகேஷன் மாஸ்டர் ஃபெயில் ஆச்சுன்னா அது வந்து டேட்டா நோட் 2க்கு கொடுக்கும். வேற எதனா அப்ளிகேஷன் மாஸ்டர் ஆக்ட் ஆகிக்கும். இப்போ 10 எம்ப்ளாய் அவர் சொன்ன மாதிரி 10 எம்ப்ளாய் நேரா மேனேஜர் பேசியிருந்தாங்க. சரி, மேனேஜரா மாஸ்டரா? ம் அப்படியே போட்டிருக்கேன். ஒருத்தர் கோஆர்டினேட் ஒரு இப்போ அந்த ஜாப் 10 சர்வரில் ஓடுதுன்னு வச்சுங்கப்பா, ஒருத்தர் ரெஸ்பான்சிபிலிட்டி எடுத்துக்கும், லீடரை எடுத்துக்கும் மாஸ்டர். சரியா? ஸோ அப்போ என்ன ஆகுனா இப்போ ஒரு நோடு ஃபெயில் ஆனாலும் இப்போ இன்னொரு நோட்ல அப்ளிகேஷன் மாஸ்டர் ஓடிடும். அப்போ அந்த ஜாப் வந்து ஃபெயிலே ஆகாது. டவுன் டைமால ஒரு ஜாப் ஃபெயில் ஆகாதுப்பா. எப்படி டவுன் டைமால டேட்டா லாஸ் ஆகுமா? வேற நோடு ரெக்கவர் பண்ணிக்கல. அதே மாதிரி தான் இது. 3 நோட்ல அந்த ஜாப் ஒன்னாலும் ஒரு நோடு மாஸ்டரா இருக்கும். இப்போ அந்த நோடு ஃபெயில் ஆச்சுன்னா அந்த மாஸ்டர் இன்னொரு நோடுக்கு போயிடும். சிம்பிள். இப்போ அந்த ரெட் இது ப்ளூ எல்லாம் பாருங்க, எல்லாம் ப்ளூ எங்க பேசுது? அப்ளிகேஷன் மாஸ்டர். அப்போ ஜாப் ஃபெயிலியர் இந்த இடத்துல எதுவுமே கிடையாது. ஏன் அப்படின்னா அப்ளிகேஷன் மாஸ்டர் ஒன்லி வில் பி கண்ட்ரோலிங் த ஜாப். Status of the jobs running across the multiple nodes will be taken care by one application master. Finally, application master only will reply the status to the application manager. Management of the job is not with the application manager now. Only monitoring of the job is only with the application manager. Management of the job is now with the application master. மூணு டிஃபரெண்ட் ஜாப்னா என்னது? மூணு நாலு நோட்லயும் ரன் ஆகுதுப்பா. டேட்டா எங்க எங்க இருக்கோ அங்கங்க தான் ரன் ஆகும். புரியுதா? 10,000 நோடு இருந்தாலும் நீங்க காப்பி பண்ற டேட்டா 10 நோடுக்கு தான் வருதுன்னா 10 நோட்ல தான் அந்த ஜாப் ஓடும். ஆமா. இப்போ ரெடியூசருக்கு இதுக்கும் கம்பேர் பண்ணாதீங்க. சிம்பிள். இப்போ நோடு மேனேஜர் டாஸ்க் ட்ராக்கர் சொல்லிட்டேன். டாஸ்க் ட்ராக்கர் கீழே ஜாப் ஓடுதா? ஒன்று ஒரு ஜேவிஎம், ஒரு ஜாபும் ஒரு ஜேவிஎம். ஒரு ஜேவிஎம்ல நிறைய இன்ஸ்டன்ஸ் கிரியேட் ஆகும். அந்த இன்ஸ்டன்ஸ் கிரியேட் ஆகுது பாருங்க, அதுதான் கண்டெய்னர். அந்த இன்ஸ்டன்ஸ் கிரியேட் ஆகும்போது அந்த ஜேவிஎம் வந்து அக்ராஸ் மெமரி யூட்டிலைஸ் பண்ணிட்டு இருக்கோம். அதை வந்து கண்ட்ரோல் பண்ணி உன்னோட ஜேவிஎம்க்கு இவ்வளோதான் மெமரின்னு சொல்லிடும். அதான் கண்டெய்னர். அந்த கண்டெய்னர்ல இப்போ 3 சர்வர்னா 3 ஜேவிஎம் 3 சர்வர்ல ஓடிட்டு இருக்கோம். என்ன ஓடும் போது ஏதாவது ஒரு ஜேவிஎம் வந்து மாஸ்டர் ஆக்ட் ஆகும். அது எதுக்கு மாஸ்டர் ஆக்ட் ஆகுதுன்னா டிபெண்டன்சி ஆன் தி ஜாப் ட்ராக்கர் ரெடியூஸ் பண்ணுது. ஜாப் ட்ராக்கர் ஃபெயில் ஆச்சுன்னா ஜாபும் ஃபெயில் ஆகிடும். இப்போ வந்து அந்த 3மே ஜாப் ஓட்டுது, ஆனால் அதில் ஒருத்தர் லீட்ரு. இப்போ லீடரும் மனுஷன் தானே, உங்கள் டீம் லீடரும் மனுஷன் தான். அவன் லீடராக இருக்கவாசி அவனுக்கு புதுசாக டிஃப்ரெண்ட்டான பர்சன்லாம் கிடையாது. அவனும் மனுஷன், உங்களை மாதிரி அவனும் ஒர்க் பண்ணுவான், ஆனால் அவன் ரிப்போர்ட் பண்ணுவீங்க. கரெக்டா? சேம் கான்செப்ட். இப்போ அவனும் ஒர்க் பண்ணுவான், ஆனால் அவன் ரெஸ்பான்சிபிலிட்டி எடுத்துக்கிட்டு ஈ வில் மேனேஜ் இட். If he is going on leave, we will assign the team leader position to another person. அதான் அப்ளிகேஷன் மாஸ்டர் பண்றது. இப்போ எல்லாத்தையும் கண்ட்ரோல் பண்ணிட்டு நாளைக்கு மேனேஜர் வந்து ஸ்டேட்டஸ் கேட்டார்னா டீம் லீடர் ஸ்டேட்டஸ் மட்டும் கொடுப்பாரு. மேனேஜர் மாறினாலும் லீவ் போட்டாலும் வேலை பாட்டு ஓடிட்டு இருக்கும். அதான் கான்செப்ட். புரியுதா? ரெடியூசர்லாம் குழப்பிக்காதீங்க. It will itself allocate capacity. It will renegotiate that. Another resource negotiate means it will negotiate the resource while processing. If it needs more, it will negotiate based on available. It will give if it is requesting, but the server does not have capacity means it has to wait. It will negotiate for that. Predefined. First it will allocate predefined, then it will negotiate again. It will request again. It will tell I need more space, I need more resource, give me. It will check the availability of the resource and it will reallocate again. Irregular communication between the nodes in terms of data level, not status level. Yes, or bit level. Clear? யார் மாஸ்டர் நம்ம சொல்லவே முடியாது. எதுனா ஒன்று மாஸ்டர் ஆயிடும். இல்ல நம்மளுக்கு தெரியாதுல்ல எது மாஸ்டருங்கும் போது. எது மாஸ்டர் இருக்கோ அது ஆர்ட் நினைப்போம். இப்போ இது டூ வே தானே. இது கம்யூனிகேஷன். கண்டெய்னர் பேசும், நாளைக்கு அப்ளிகேஷன் மாஸ்டர் டவுன் ஆச்சுன்னா வேற அப்ளிகேஷன் மாஸ்டர் வரும். அவ்வளவுதான். சரியா? யூஐல பார்க்கலாம் நம்ம அந்த அப்ளிகேஷன் மாஸ்டர் எந்த சர்வர்ல ஓடுதுன்னு பார்க்கலாம். அது பார்க்கலாம், அது காமிக்கிறோம். ஓகேவா? கிளியரா? கிளியர்? டவுட் வேற எதுனா?
கிருஷ்ணா?
எஸ் அனி சொல்லுங்க. எஸ் அனி.
ஓகே. சோ இங்க வந்து கண்டெய்னர் வந்து பிளாக் மாதிரியா? இல்ல,
கண்டெய்னர் வந்து ஒரு ஜேவி.
இங்க பிளாக் கான்செப்டே கிடையாதா?
அதெல்லாம் ரிமைன் சேம். பிளாக், ஹெச்டிஎஃப்எஸ் எல்லாம் சேம் பா. ஜாப் ட்ராக்கர், டாஸ்க் ட்ராக்கர்ல மட்டும் மாற்றம்பா, அவ்வளவுதான், வேற ஒண்ணுமே இல்ல. கண்டெய்னர்னா அது ஒரு உங்களுக்கு புரியறதுக்காக இது ஒரு ஸ்பேஸ் இது அலோகேஷன் மாதிரி சொல்றேன் நான், வேற ஒண்ணுமே இல்ல. இப்போ 100 percent CPU னா 20% ஒரு கண்டெய்னர் அது உள்ளதான் ஆபரேட் பண்றது தான் கண்டெய்னர். So anything you have to do within that only, that is called I'm saying as a container. ஓகேவா?
ஓகே. சோ அந்த டேட்டா ஸ்ப்ளிட், the 64 MB அதெல்லாம் எல்லாமே ஒண்ணுதான்,
எல்லாம் சேம். ஜெனரேஷன் 2ல 128 MB மினிமம் ஸ்ப்ளிட்.
64 MB க்கு பதிலா 120 MB.
128 அவ்வளவுதான், வேற எதுவும் பெருசா டிஃபரன்ஸ் இல்ல. ஓகே.
இப்போ ரிசோர்ஸ் மேனேஜர் ஃபெயில் ஆயிடுச்சா என்ன பண்ணுவீங்க?
ஓகே, ரிசோர்ஸ் மேனேஜர் ஃபெயில் ஆனாலும் திருப்பி you can bring up the resource manager. Only the thing, right, you cannot submit any new job, but the job which is running will not be affected because the connectivity between the resource manager and the node manager is only status, that's all. Controlling will not be done by the resource manager, only the status. Only first time submitting the job will be taken care by scheduler and application manager. Rest of the things will be taken care by application master only. So whenever you want to status, application manager will connect to application master and get the status. So if the application manager down also, the job will not fail. If 1000 job is running, the resource manager failed as well, there will not be impact to the job which is running. You remember while running job history server, the history of the job will be maintained by the history server. You remember the previous class and all, it will say job history server not found. So it will be managed by the job history server only. Okay, Lawrence, doubt? Clear? Okay, fine, we'll move, right? So now எதுக்கு வேணாம்னா நீங்க எக்ஸ்டெண்ட் பண்ணிக்கோ, அது ஆட்டோமேட்டிக்கா எக்ஸ்டெண்ட் பண்ணிக்கோ. என்னப்பா டவுட்டு? கண்டெய்னர் அப்ளிகேஷன் மாஸ்டர். So now this is a folder structure for this. So here the configuration file will be present under the etc Hadoop configuration will be there. Okay. Here you will have the core site XML, same as the generation 1. There is no change to that. And HDFS as well. There is no change to that. Only the change to MapReduce site XML. MapReduce site XML. So you will specify MapReduce framework will be yarn, which means it will be using yarn architecture. Okay. So system directory, local directory remains same. Only in the yarn site XML, you have to specify this aux.service. This one you have to specify. This two you have to specify auxiliary service in the yarn. Okay. So that any Spark, anything you have to install, you have to download a Spark with yarn based framework you have to install. Then only yarn will be used. Okay. Configuration same. There is no change to that. Only MapReduce and yarn you have to change it. Other than that, everything is same. So now, so here I have a document for 2.4 setup. Just you can follow the setup. Okay. So everything is same. So this all remains same. So but in the batch profile, you have to configure this many settings. Okay. Java 7 is required. So MapReduce, core site XML, HDFS site XML, everything remains same. Okay. MapReduce alone you will change to yarn. That's all. Yarn site XML you have to add this. Other things are same, remain same. Okay. So now we are going to start yarn. So to do this, you can also do start-all.sh or start-dfs.sh. It will start only the name node and data node. Start-yarn.sh. So this will start the resource manager, node manager. And added to that, we have to start the job history server. Okay. Yarn will start resource and node. In different node manager. Different node. That is, yes, one resource manager, multiple node manager. Here also you can start. Similarly, we did in generation one, right? Start-all. It will start data node and task tracker in different server, name node and data node in one server. Same concept. Mm. Huh? Sudo? Same. Same. Everything is same. Only the processing alone you have to change. Only the it is changed into yarn. Rest of the things, your same program which is running on generation 1, it will run on generation 2 as well. Only how the way how it is running is different. That's all. So history service required. After that, you can manage. You can look at the DFS cluster job history. Here there is no job tracker. Okay. Hmm. So physically they will not have all cloud based virtual machines. They will use. They will destroy it. But in interview, don't say 1,000 node and all. Say 21 or 25 node and all. Okay. One interview, one guy said 2,500 nodes. His company was some Balaji Infotech. Okay. So now, see here, it's a cluster. Okay. So everything will be same like live nodes, dead nodes. Everything will come same. Everything remains same. There is no difference on that. So now, here we call as an application. Okay. So in this application, if you see here, submitted job, accepting, running, finished, killed, scheduler, the scheduler concept we have seen, right? It will come here. So now what I will do, right? I will submit a job. Hmm? Okay. So this is the job I am submitting. So now I am submitting the job. Okay. Everything, sir. So use this script to execute HDFS command instead for this. Instead use the HDFS command. From Hadoop it will change to HDFS. Okay, that's the reason in that document, right, I have used HDFS. So that is the command for both generation 1 for generation 2. So that administration document will have both the things. Okay. So now submitting the job. Okay. So now the job is submitting. Here you see you see capacity by default it is 0% used. Can you see? Application queued 0% used. So no jobs is running. So now you see 25% it is using for one job. Remaining 70% is free. Okay. So this is the job which is running default queue and it's an application. Job is accepted and it's running. Okay. So you can monitor the capacity over here and you can monitor the running job over here. Which are the job is running, what is the application. You can go ahead and see which node is being used, what is the accept number. If you want to track the application master, can you see that? Now resource manager is navigating to application master. So a single application will have application master. Can you see this? If you want to know the status of the job, you have to go to the application master and see it. Application master only will connect and give you a high level status of your job. If you go to application master, so you go here, again it's an internal job only. Clear? It is a map reduce jobs only. You see map reduce application, internal it's a job, but one will be controlled by a application master. Application master will respond to the status of application manager. So what you see over here is a application. Here it's application. This is an application manager. When you go to application, it will go to the application master. The respective application master, you can go to this, click the job, you will see map reduce. Okay. So this map and reduce is called the container. So if you look at here, okay, map reduce is completed. Okay, you will see the number of jobs over here. Map 100%, reduce 100%. Okay, and you see the logs of this. So this is the total number of jobs, running jobs. because here everything is Ubuntu. Okay, and the transaction we have to see any data is there. Okay, if you go to the task, logs of the task, counters. Okay, so we are using a counter in that program. Counter is not available in 2.0. That references point will be changed in counters in 2.0. So because of that, it is failing. Clear? Okay. So you can control everything over here. The understanding is master. Okay. So counter in generation 2, what is that? Hadoop generation 2. Mhm. Okay. You got it right. Eye level, how it's running. Manager, master, and then actual job it will come. Actual job only map reduce. Again, it's map reduce only. The way it is being managed is now different. Yarn is not a replacement for MapReduce. Yarn is a management to control the MapReduce jobs. That's what I'm saying. Okay. Yarn is not a replacement. Spark only is a replacement for MapReduce jobs. Clear, appa? Yarn like a controls. It controls the way the job has been submitted and managed. Spark வந்து ஈவினிங் பேட்ச் அது நீங்க ஜாயின் பண்ணீங்கன்னா அது எடுப்பேன். எடுப்பேன்னு அவர் கேட்குற ஸ்பார்க் நாளைக்கு ஆரம்பிப்பீங்களான்னு கேட்குறாரு. இப்போதான் எடுத்துட்டேன் ஸ்பார்க் சொல்லி கொடுத்தேனே ஹை லெவல். ஸ்பார்க், காஃப்கா, மஹூத், ஸ்டாம், ரெடிஸ், ஸ்கேலான்னு ஒரு லாங்குவேஜ். ஜாவாலையும் பண்ணலாம், ஸ்கேலாலையும் பண்ணலாம். ஆனால் மேஜரா ஸ்கேலா. அது நம்ம செப்பரேட் ட்ரைனிங்ல பார்ப்போம். ஒரு கீ வேல்யூ டேட்டா பேஸ் இது. டிஸ்ட்ரிபியூட்டட் கேட்ச் டிஃபரன்ஸ் இருக்கு. ஆமா, வெறும் அதுல வந்து ஜாப் டாட் கான்ஃபிகரேஷன் டாட் டிஸ்ட்ரிபியூட்டட் கேட்ச் இருக்குல்ல, அது வந்து ஜாப் டாட் டிஸ்ட்ரிபியூட்டட் கேட்ச், அந்த ஜாபுக்கு மட்டும் ஆட் பண்ணணும். அந்த மாதிரி மைன்யூட் டிஃபரன்ஸ் தான். நீங்க அந்த லைப்ரரி யூஸ் பண்ணும்போது அது டிப்ரிஷியேட்னு காமிக்கும், நீங்க அப்போ சர்ச் பண்ணிக்கலாம். இப்போ ப்ரோக்ராம் அந்தந்த கிளாஸ் யூஸ் பண்ணும்போது உங்களுக்கு தெரியும். மேஜரான டிஃபரன்ஸ் கிடையாது. அந்த கவுண்டர் இருக்கும், ஆனால் அதோட கிளாஸ் வந்து வேற இடத்துல மாறி இருக்கும். இப்போ டிஸ்ட்ரிபியூட்டட் கேட்ச் இருக்கும், அது கான்ஃப் டாட் டிஸ்ட்ரிபியூட்டட் கேட்ச் கிடையாது, ஜாப் டாட் டிஸ்ட்ரிபியூட்டட் கேட்ச். அது மாதிரி அந்த கிளாஸ் வந்து மாறி இருக்கும். ரெஃபரன்ஸ் லைப்ரரிஸ், அந்த ரெஃபரன்ஸ் லைப்ரரி மட்டும் நீங்கள் எடுத்துக்கணும். இப்போ கேட்லாக் பார்த்தீங்கன்னு வச்சுக்கோங்க, நான் உங்களுக்கு கொடுத்தது ஆர்க் டாட் அப்பாச்சி டாட் அடூப் டாட் பிக் டாட் கேட்லாக். பட் பார்த்தீங்கன்னா லேட்டஸ்ட் லைப்ரரியில் ஆர்க் டாட் அப்பாச்சி டாட் ஐவ் டாட் பிக் டாட் கேட்லாக், இது அந்த லைப்ரரி ரெஃபரன்ஸ் பாயிண்ட் மட்டும் தான் மாறி இருக்கும். அது மட்டும் பார்த்துக்கணும். கிளியரா? ஜெனரேஷன் 2 அதுலயே ஸ்பார்க்குள்ளே அது வந்துடும். பிக் ஸ்டில் ரிமைன்ஸ், ஐ வந்து ஸ்பார்க் கியூஎல் ஆயிடும், மகூத் வந்து ஸ்பார்க் எம்லிப் ஆயிடும், ஸ்பார்க் எம்லிப். ஸோ அது மாதிரி அது நிறைய இருக்கு. ஸ்பார்க்கே ஒரு 5 வாரம் ஆகும் கிளாஸ். அது ஒரு பெரிய கிளாஸ். ஓகேவா? முடிஞ்சுதா? எதனா குறைகள் நிறைகள் என்ன சொல்லுங்க. கிளியர் ஆனி அண்ட் ஐயப்பன்? ஜெனரேஷன் 2 பெருசா இல்லை. அந்த எப்படி அந்த ஆர்கிடெக்சர் வந்து சேஞ்ச் பண்ணிருக்கோம் ஜாப் ட்ராக் டாஸ்க் ட்ராக் பிரகாரம், அதான் டிஃபரன்ஸ். மற்றபடி மேப் ப்ரொடியூஸ் எல்லாம் ஸ்டில் ரிமைன் சேம், ப்ரோக்ராம் எல்லாம் ஸ்டில் ரிமைன் சேம். நீங்க அந்த ப்ரோக்ராம் வந்து ஜெனரேஷன் 1 ப்ரோக்ராம் ஜெனரேஷன் 2 ரன் பண்ணும்போது வெறும் ஜெனரேஷன் 2 லைப்ரரி வச்சு கம்பைல் பண்ணி பாருங்க. இட் வில் throw some error, this library is missing. That library, right, if you find that for generation 2 it will take r.apache.counter. Like that it will change, that's all. That concept will still remain same, only the library usage will be different. Why? Because while running MapReduce job, right, counter has to be maintained in a job. Since it is yarn based, right, they will change the reference point for the library, that's all. So similarly, distributed cache also is a job based. So previously it was configuration based, now it's a job based. Clear? சிரிப்பு தான் நான்கு. யான் பாது ஞான் இல்ல, ஞான் இல்ல யான் அது. ஆனி ஐயப்பன், எனி டவுட்? எனி டவுட்? ஓகே. D3JS. ஓகே, சிம்பிள். இங்க பாருங்க, சரியா? இது எது வேணாலும் யூ கேன் கால் மீ, சரியா? சரியா? See, very simple. Any of these things, okay? So latest, if you see Microsoft Streaming Analytics, then one more is Amazon Machine Learning. சரியா? இதுல எதா இருந்தாலும் யூ கேன் கால் மீ. ஆமா, அமேசான் மெஷின் லேர்னிங், ஸ்ட்ரீமிங் அனாலிட்டிக்ஸ், இன்ஃபோசிஸ் டீம்ஸ், மைக்ரோசாஃப்ட் ஈவெண்ட் ஹப், அஷூர், அமேசான் EC2. சரியா? டெக்ஸ்ட் மைனிங் வந்து ஸ்ட்ரீமிங், இது சென்டிமெண்ட் அனாலிசிஸ் அந்த மாதிரி. சரியா? ஸோ இது எது இருந்தாலும் சொல்லுங்க. எனி ஹெல்ப்னா அதுக்கப்புறம் பின்னாடி வந்து மற்ற டீட்டெயில்ஸ் எல்லாம் வரும். சரியா? சரி, அப்படியே ஒரு ஹை லெவல் சொல்றேன், உங்களுக்கு எல்லாம் யூஸ்ஃபுல்லா இருக்கும். Hadoop பார்த்தோம், ஐவ் பார்த்தோம், பீக் பார்த்தோம். அட்டானமி உங்களுக்கு தெரியா? வாட்சன் தான் அட்டானமி. அட்டானமி ஈக்குவல் டு வாட்சன், சிம்பிளா. ஓகேவா? அது ஐபிஎம் ப்ராடக்ட் ஒன்று. வர்டிகா வந்து இட்ஸ் அ டேட்டாபேஸ், இட்ஸ் அ காலம்னார் டேட்டாபேஸ். Cassandra, HBase, all comes under the same line. Okay, Cassandra வந்து peer-to-peer communication. So 6 nodes means 6 nodes will have same data. Mahout machine learning algorithm. Okay, Nutch Apache is a crawler, distribute crawler. When you want to crawl the data from different server, Nutch will be used. Tika is a content parser. So if you have a PDF, Word document like that, if you want to extract a content out of it, Tika will be used. From an HTML, you want to only get a text. That kind of a content parsing is called Tika. Solar is like a elastic search engine, indexing based search engine. LA uses Solar at the background. SAS is statistical software that you know. Spark we have covered. Scala is like a Java. Apache Lucene. Solar uses Apache Lucene for text term indexing. Okay. Storm we have seen. Kafka we have seen. Trident. Trident is the abstraction layer of Storm. Okay. Abstraction layer of Storm. Data science you know. Machine learning you know. This R is used for statistics algorithms. Ripe, which sets on R for distributed R processing. Okay, which can integrate with Hadoop. Hadoop also same concept with integrate with Hadoop. Analytics, predictive analytics, more of forecasting. Data warehousing, data modeling, factors, dimensional modeling, star modeling, all those things. Business intelligence, more of visualization. D3JS, Canvas, Facet, jQuery based reporting, response UI, SSRS, Cognos, like that. So to me, SSRS, business objects, ClickQ, Tableau. So these things you can reach me. Okay, I can teach you. .NET if you want, I will teach. Base .NET தான் கேள்வி கேளுங்க .NET தெரியுதோ Scoop, we have seen Flume, we have seen data mining, data manipulation, data cleansing, querying, everything comes under this. More of transformation. On what basis you transform a data. Text mining, more of text analytics, machine learning on text data, clustering classification on text data. Image mining is pattern mining, identifying a pattern of an image. .NET, C#, .NET, ASP, that full flavor, anything you can ask. SSIS, SSRS, SSAS, KP reporting, customization, product building, anything. Java, Python, that's a language. EC2, it's a Amazon EC2. It's a elastic computing where you can go and get your cloud servers and do whatever you want. Okay. Windows Azure, it's like Amazon EC2. It's very good with compared with Amazon. So Microsoft Event Hub, it's for streaming data processing. Kafka we have seen, right? Similarly, Event Hub is a product like Kafka. So as and when the event comes, the consumer can consume. That is the Event Hub. InfoSphere Streams is equal to Storm and Spark streaming. It is a IBM product. Okay, but it's a very good product, InfoSphere Streams. So Microsoft Streaming Analytics is equivalent to Spark streaming. I said right. SQL based streaming analytics is Microsoft Streaming Analytics. Azure, Amazon Machine Learning, it's like a machine learning on the fly. You don't need to write any algorithm. You give the data in a UI base, you can select it. So added to this recently, I updated Databricks. So Databricks is a cloud-based machine learning mechanism where you don't need to care for your infrastructure. It will be automatically taken care. So these are all things. So many things is available. So apart from this is a high level which is required. Added to the subcomponent like Apache Meos, Apache Ambari, Apache Crunch, Apache Drill. Okay. So all these things are subcomponent, that is like bits and pieces. So you can take down all these names: Apache Drill, Apache Spark, Apache Meos, Apache Ambari, Apache Crunch. Okay. And Madlib. Recently, one more thing called Madlib. MAD, M-A-D, Madlib. Axe Shell. That is new programming that is very popular in the market. And CMU Phoenix for video processing and audio processing. These are libraries. Okay. So, oh, n number of tools are available. SAS, R, SPSS, Rapid Miner. One more thing I recently did. Rapid Miner. Rapid Miner. That's what. So Rapid Miner is a UI based like SPSS. Rapid Miner. Okay. Huh? So all these things, right? It is a tool based. So lot of things are cost based, not open source based. Where it is used? Real time example: prediction of stock. Tomorrow rain will come or not? Non will clear the interview or not? We can predict. Both predict and machine learning, there is a minute gap. That's all. Machine learning, you based on the past data, you predict. If I show you a color, will you identify or not? How you are identifying? How you know already? Because your brain is trained like that. So based on past, if I put you in a new place, you have not seen that place, you will learn from that place. That is machine learning. Okay, clear? This is the things. So any of the things, any help, you can contact me. Post that, we'll have discussions. So now machine learning is converted to deep learning. Artificial intelligence is a part of machine learning only. Neural networks, all that comes under machine learning. Fine. படிக்குதாங்க. அந்த மாதிரி இது இல்ல. Hadoop ரிலேட்டடே கிடையாதுப்பா. மொத்தத்தையும் சேர்த்து பண்ணீங்கன்னா நீங்க ஒரு கலவை. Hadoop, டேட்டா சயின்ஸ், விஷுவலைசேஷனு, ஓகே, மொத்தமா சேர்த்து பண்ணீங்கன்னா அது ஒரு டேட்டா சயின்டிஸ்ட் ரிசோர்ஸ். இப்போ பாத்தீங்க சிம்பிள். அதெல்லாம் நாளைக்கு பேசலாம். இன்னைக்கு ஹை லெவல் நீங்க கேட்ட இன்ட்ரெஸ்டா கேட்ட சொல்றேன். Flipkart, Hadoop. சரி, Flipkartல ரெண்டு இருக்கு. ஒன்னு டே டு டே பிசினஸ் ஆக்டிவிட்டி, இன்னொன்று வந்து ஃபோர்காஸ்டிங் ஆக்டிவிட்டி. டே டு டே பிசினஸ் ஆக்டிவிட்டி வந்து அந்த ஃப்ரண்ட் எண்ட் டெவலப்மெண்ட், ஃபோட்டோஷாப்ஸ், அந்த இமேஜ் டிசைனிங், ப்ராடக்ட் கேட்டகரைசேஷன், எவ்ரி திங் வில் கோ. பட் below that Flipkart, you see people who buy this also buy this. That's all analytics. Okay, and as well as when you have a 1, 2, 3, see the product, feel the product, buy the product. That reduction of the number of sequence. So previously there is a you have to log in, register, give your biodata, then only you can purchase the product. Now without that, create a user ID, buy the product. So that enhancement all brought up by the data sciences person only. So you will find out people how they are navigating, why they are not purchasing when they come to the payment site, what are the offers we can give, how they use Hadoop. Flipkart uses Hadoop extensively. Visualization. So right now what we are seeing is as a end customer, we are seeing as a user of a product. At the background they will use visualization, real-time visualization. Apache Nutch they are using. Nutch. HP uses Apache Nutch. D3JS, Canvas.js. Visualization. Open source all comes under D3, Canvas.js, jQuery based reporting, Google Charts, rgraph, Protovis, everything it will come. Okay, but the enterprise view, Tableau, ClickView, Spotfire, that are the peak now. Recently 2 more tools came into the market. ஆமா, அதான் visualization. Tableau, Spotfire. Right. So it's a very good question. நீங்க வாங்க போறீங்களா? So இங்க பாருங்க, you know we are going to see tomorrow. இப்போ லாரன்ஸ் கேட்ட வாசி இதான் ஃபுல் ஃப்ளோ. இப்போ கவர் பண்ணிட்டோமா இதை? So anyway, no, okay, then we'll see tomorrow. So this is the answer for your question. What is the full flow? What level you have to pick which component? Okay, that is a tomorrow's architecture class. We'll have it. So பாக்குறங்க இல்லைனாலும் நாளைக்கு எக்ஸ்பிளைன் பண்ண போறேன். Okay, that's it. With that, we are completing all the thing. Now you are an expert Hadoop developer. Okay, Kumar. Now you are an expert Hadoop developer. With that, we are completing everything. Tomorrow, it's only a discussion of architecture situations project. Interview questions. I will give that. அது நாளைக்கு சொல்றேன். ஓகேவா? ஃபைன் ஆனி, ஃபைன் ஐயப்பன். Okay. So with that we are completing. We'll meet again tomorrow 8 a.m. I guess tomorrow 10-11 முடிச்சலாம். நீங்க கேட்குற கேள்விகளை பொறுத்து இருக்கு. சரி, listen this. Right now I've used all your Hadoop cluster for this one. So right now again you format and correct it. Format, change the master to localhost. Master to localhost and master file and slave. Ayappan, don't join that Spark class. I will call you. Okay. 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 Fine. Bye. Take care. We'll meet tomorrow. Is there any questions, Annie? Ayappan, can we close the class? Yes or no? You are there already. You already left.
Yes, Guru, we can close.
Yes, we'll connect with you, Annie. I will call you. Okay. Okay. Bye now. Bye.